Alright, hello everyone. Thank you for clicking on this video. I hope you find it informative and helpful. This is just going to be a series of practice questions for the GRE quantitative section. The link for the book that I took this from is going to be in the description below where you'll find it, and then you can find also a link to my tutoring channel if you want to look there as well for some support on the GRE. The only thing to do now is go through the questions. When you go through them, this is kind of the method that you should do. You should do kind of a three-step method. The first one is that you should read the question and pause the video. Alright, so you'll see usually a question will usually be over here, and then my picture will be over here. And I want you to pause the video first, try and do the problem. Alright, so that's number 2. Try to do the problem. And then the next thing that you need to do is after you've given an attempt, you don't need to think too long about it, because the point of practice problems isn't necessarily to see if you can do it. It's to get a familiar feeling for how problems are presented and how concepts are applied. So try and do the problem, but don't spend too much longer than a minute or 2 minutes on it. Then after you've given an attempt, regardless of whether you've successfully done the problem or not, the third step is to continue the video and listen to the explanation. Alright, so that is the final step. And what you're going to see in this video is just a series of something like 50 questions. They're going to all follow the same pattern where I introduce the problem, ask you to pause and try the problem, and then continue and listen to the explanation. After you go through all of them, hopefully that will have helped you learn a little bit more about the quantitative section and developed some better understanding of the math portion. If you run into something that you don't know, I highly suggest writing it down, either formulas or concepts that have been used, and creating some sort of running list of math concepts that you can look at as you prepare for the GRE. Thank you so much. I hope you enjoyed the video, and yeah, with that, we'll just continue. Okay, why don't you take a second to look at the problem and see if you can figure out what the answer is. I will pause, and then you pause the video yourself and try and answer it, and then we will jump right into the explanation. Okay, so to solve this problem, they're saying that PQ is equal to PR, right? So PQ right here, this right here is equal to this right here, and these two lines mean PR and PQ. However, they want to know, is PS equal to SR? Now we know this is a triangle, we know these two are the same, but the truth is that you can draw this triangle in multiple different ways. So I can draw two identical triangles, and let's pretend that I'm able to draw them correctly, like this. So they're equal. And nothing else is given about this shape, right? And it's not necessarily drawn to scale. So this line could have be drawn this way, right? So S could be here, or it could be drawn all the way over here. Alright, so because this isn't necessarily drawn to scale, then either of these could be the actual look of the image. Now if this is the actual look of the image, then PS, or PS right here, is greater than SR. Oh, sorry, PR. Yeah, SR. And if this is the actual image, then PS is less than SR. Now since you can have both this or this, you're sitting in a situation where the relationship cannot be determined from the information given. So your answer is D. Okay, so why don't you take a second to try and do the problem, and then after you have done that, you can pause the video, and then after you've done that, we'll go through it. Okay, so this problem is set up with two parallel lines. You know that line K is parallel to line M. So these two lines are parallel. The way that I will indicate that is by drawing these two arrows. Now, I'll draw it over here. Whenever you have two lines that are parallel, like this, pretend these are parallel lines. In fact, let's do that a little bit better, if we can. Yeah, it's a little better. Okay, whenever you have two lines that are parallel and a line goes through it, you see the same angle happening on the opposite side, like this. So this angle right here, let's call it A, is going to be equal to angle B. Same thing on the other side. So this angle C is going to be equal to angle D. Okay, so that's just kind of a property of when you have two parallel lines and then you take another line and you go through it. Again, you'll have parallel lines. And I'm just drawing three lines here to denote that these angles are different from these. So this will be 4. And this will be 4. So that's kind of the property that we're going to use here. So what you see here is that the two quantities, quantity A and quantity B. Quantity A is going to be that x is s plus x plus y. The second quantity is going to be w plus z. Now, what's important to note is that when you have these two angles and you have a line going through them, these two inside angles are going to be the same. So w is equal to y, and x is equal to z. So we can rewrite x plus y, if these equations hold, as z plus y is equal to w plus w. So this is this, and therefore what we're seeing is that quantity A is equal to quantity B, because x plus y is the same thing as w plus z, because x is the same thing as z in terms of the degrees, and y is the same thing as w in terms of degrees. The reason why is because you have two parallel lines, and you have a line going through these parallel lines, creating similar angles like this. Alright, great. So the answer is going to be C. Two quantities are equal. Okay, so why don't you take a second to see if you can answer the problem, and then we'll remove the pause video sign and we'll get to it. Okay, so this is asking you about decimals that are repeating. So it says in a decimal number, a bar over one or more consecutive digits means the pattern of digits under the bar repeats. So they give you the first example, which is 0.387, and that indicates 0.387, 387, 387, dot, 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 dot. This just means that it's going on and on and on forever. So what they're giving you, they're just giving you two different options. The first one is 717, the second one is 71. So we can actually write these out and see very quickly which one is larger. If we go with quantity A, we're going to see 717, and then this is going to be repeating. So then we're going to see 717 again, and then 717 again. We look at quantity B, we're going to see 0.71 repeating, so there's going to be 0.71, then we're going to repeat that, 71 repeated again, 71 dot 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 dot. So now we can start comparing decimal places. As you can see, these are both 7, so they're the same. These are the same. They're both 1. These are the same. But then when we get to the fourth decimal place, this is a 1, and this is a 7. And at this decimal place, 7 is much larger than 1, therefore A is going to be larger than B, and therefore the answer we're looking for is going to be A. Quantity A is greater than quantity B. Okay, so why don't you take a second, try and do the problem, and then when you are done, you can replay the video, or you can start the video again, and then we can go over the problem together. Alright, so let's get rid of that. Now, this is talking about percentages equaling other percentages, right? So what they're saying is you have 4% of s is equal to 3% of t, and they also let you know that s is greater than 0 and t is greater than 0. Okay, so if s is greater than 0 and t is greater than 0, then you can write out this 0.04, that's the decimal version of 4%, of s is equal to 0.03, which is the decimal version of 3%. So this is 3%. That's 4%. So that is kind of what we're saying. They're saying 4% of s, which is right there, s times 0.04 is equal to 3% of t times 0.03. Alright, so that's our equation. Now, if you had 0.05% of s, or 0.05 of s, is equal to 0.05 of t, the only way this could be true is if s was equal to t. Right? Because that would be 0.05 of the same thing being equal to each other. If s and t were different, then this wouldn't work. Alright, so this is the case, then s and t are equal. What happens if s is 0.04 and t is 0.03 and they're equal to each other? This means that 4 100ths of s is equal to 3 100ths of t. Or in other words, less of t is needed to equal more of s. Alright, so t is actually going to be greater than s, and therefore you only need 3% of it to equal 4% of s. Alright, so because you can see that this number is smaller, 0.03 instead of 0.04, you know that this number has got to be bigger than this number in order for this equation to balance out. And that's how you know that t is greater than s. So quantity B is t, so we're looking at answer B, which is that quantity B is greater than quantity A. Okay, so I want you to take a second and try and solve the problem, and then when you are ready, just continue the video. So here you can pause it and attempt to do the problem, and then after you're done, or you're ready to continue, just unpause the video, and then we will go over it. Alright, great. So, the problem here is circles within circles, and it says there are 3 circles, so the first one is the larger one, the second one is the second larger one, and the third one is the smallest one. And it says these 3 circles have a line. This line is PRQ, and their tangent at points PR and Q. So this circle touches the tangent of the larger circle at this point. These 2 circles touch each other at their tangents right there, and then the smallest circle touches the largest circle here at a tangent point. So that is the information that is given. And then it wants to know what is larger, the circumference of the largest circle or the sum of the circumferences of the 2 smaller circles. So the formula you need to know for this one is that circumference is equal to diameter times pi. Alright, maybe that's usually D capitalized, but it's circumference is equal to diameter times pi. This is the formula that you want to know. So let's start by calling one of these different variables. Let's call this diameter x, let's call this diameter y. Alright, so from here to here is going to be y, and from here to here is going to be x. Alright, so x therefore represents the diameter of the circle that's created here. Y is the diameter of this circle, and then y plus x is going to be the diameter of the largest circle. So y plus x equals diameter of largest circle. Y equals the diameter of the middle circle, of this circle right here, middle circle. And by that I mean middle, largest, so it's not the largest, it's not the smallest. And then x is equal to diameter of the smallest circle. Okay, and this gives us, I think, basically everything we need to solve this problem. So we start off by trying to find out what this is and what this is. So remember, diameter times pi is equal to circumference. So the circumference of this circle right here is going to be equal to y multiplied by pi, because that's the diameter. And then this pi is pi. So now we look at the smallest circle. The smallest circle, if we create an arrow that goes there, is going to be x multiplied by pi. Alright, so these are the 2 circumferences of the 2 smaller circles. Now, the circumference of the largest circle is going to also be diameter times pi, so that will be diameter times pi, but diameter is this entire line, which is x plus y. So that is going to be equal to x plus y, in parentheses, times pi. which is equal to, it doesn't matter what it's equal to, it's equal to this. So this is the diameter of the largest. Now, that is going to be, I'm sorry, that's the circumference of the largest. So that is going to be quantity A. Now, what is quantity B? Quantity B is the sum of the circumferences of the two smaller circles. So these are the circumferences of the two smaller circles right here. So let's add them together, and what we get is y plus pi, y times pi, plus x times pi. Alright, now what we have here is we have pi in both, so we can remove that, and that will take you to y plus x in parentheses multiplied by pi. This equals the sum of both smaller circumferences. So this is going to be equal to b. Alright, so this is a right here, which is x plus y times pi, and this is b right here, which is equal to y plus x times pi. This obviously is the same thing as x plus y times pi, which is equal to this. So therefore, the answer is that quantity A and quantity B are equal. And therefore, of these choices, we are looking at letter C. Alright, so why don't we give you a couple seconds to try and answer the problem. And as you can see, it says pause video and attempt problem. When you're done attempting the problem and you're ready to move on, why don't you go ahead and replay the video, and then we will begin. Alright, great. So, the question has inequalities up here, and the inequality is r times t is less than 0, which is less than negative r. And if we break these into two different things, we can understand them better, and that'll help us answer this problem. First is that r times t is less than 0. Okay, now this tells you a little bit about what's happening. And what this is going to tell you is that either r or t must be negative, and the other one must be positive. Right, one of them has to be positive, the other one has to be negative. And the reason why is because a positive multiplied by a positive is always going to be another positive. Right, so like 7 times 7 is equal to 49. Things like that. 2 times 2 is equal to 4. That was 2. Doesn't matter. That's the point, right? So a positive times positive equals positive. A positive times a negative always equals a negative. So if you've got a positive, you multiply it by a negative, you're always going to get a negative. Right? So that would be 7 times negative 7, right? 7 times negative 7 is equal to negative 49. Alright, now if you have two negatives, say it's negative 7 times negative 7, that equals a positive 49. So negative multiplied by a negative is going to equal another positive. Right? So these are kind of the three general rules, and we know that whatever these two are multiplied by each other, they're going to be less than 0. Less than 0 means negative, which means one of these is going to be negative, the other is going to be positive, because that's the situation in which you get a negative number. Now, that's what we know here, but we also know this second part. So that was this first inequality. Now let's look at this second one right here. We also know that 0 is less than negative r, or in other words, negative r is greater than 0. Alright, so negative r is positive. Alright, so now with an inequality like this, you can divide by negatives in order to get a variable by itself. So you can divide this entire thing by negative 1. And then you divide 0 by negative 1. And what you end up getting is that you end up getting 0 is greater than r. Right, so this is, and what happens, sorry, just to make sure that this makes sense, when you multiply by a negative number, you always have to switch an inequality. Right, so if you multiply by this negative number, if you multiply, or you divide by negative 1, multiply or divide, you have to switch this inequality like this. So when you divide by negative 1 here, you have 0 is less than negative r, you switch the inequality, it becomes 0 is greater than r. Okay, that makes sense. Or you can just think of it intuitively. Negative r has to be greater than 0, so negative r is positive. And if negative r is positive, then r has got to be negative. Okay? That is the situation. So r is negative. R is less than 0. So now that we know that, now that we have found out that r is less than 0, and we also know that you need a positive and a negative to get a negative number, now we're in business, because we know that r has to be negative, and we know that r times t has to also be less than 0 or negative. Then we know that a negative multiplied by something has to be less than 0, which means this has to be positive, right? So a negative multiplied by a positive equals a negative. A negative multiplied by a negative equals a positive. So we need this to be a positive in order for the combination of these two things multiplied together to be negative. That means that t is greater than 0 because t is positive. All right, great. So we know that t is positive, and that's actually all we need because quantity A is t and quantity B is 0. So when it comes to which one is greater, t is definitely greater than B, like this, because t is greater than 0. So the answer is A. Circle that real quick. Okay, so why don't you take a second and try and solve the problem, and then when you have finished trying or attempting or solving the problem, then press the continue button and we will try and solve this together. Alright, great. So, this problem has to do with absolute values, and I think one of the keys to unlocking the answer to this problem is recognizing that both A and B, both quantity A and B, involve taking x and either adding or subtracting something from it, and then taking the absolute value. So x is kind of irrelevant in this problem because it's going to be the same on both sides. The question is, what is y doing in the scenario? Alright, so let's say that we have x. We can just set x equal to some number. Let's set x equal to 5. Now, if we set x equal to 5, y has to be less than x. Okay, that means that y could be something like 4, or y could be something like -7. Okay, so these are two possible options. Let's call this option 1, and let's call this option 2. Alright, now the difference between these is that y here is a positive 4, whereas y here is a -7. So you can have a positive or a negative number, and that's going to factor in. Alright, so let's try these two options and see what happens. For the first option, let's come over here, and let's do the option of 5 and 4. Right, this is where x is equal to 5 and y is equal to 4. And if we do that, we get 5 minus 4, and we get 5 plus 4. Absolute value on both of these. So that's the first scenario. And then what we end up getting is 5 minus 4 is 1, which is 1 absolute value, which is equal to 1. Alright, so that's the first one. And here what we end up getting is 9 absolute value, which is equal to 9. Now what you see here is that 9 is greater than 1. So A is greater than B. Okay? Now let's try our second scenario. Our second scenario is going to be where y equals -7. So that is 5, -7. Okay? Again, we satisfy this inequality, and it's a different value for y. Now what we get over here is we get absolute value of 5 plus a -7 this time, and we get an absolute value of 5 minus a -7 this time. Alright, so now let's look over here. We see 5 minus a -7 is equal to 5 plus 7. So here we're going to get 5 plus 7 is equal to 12. So here we get 12. And now over here we get 5 plus a -7, which is the same thing as 5 minus 7, which is equal to -2, -2 absolute value, which is equal to 2. So now, in this scenario, when we have y equaling -7, this one, we end up with 12 on the right side, which is greater than 2 on the left side. But remember, in the previous one, we had 9 on the left side greater than 1 on the right side. So now we have a situation where we found an example where B is actually greater than A, right here, and we found an example where A is greater than B. So now that you're able to go both directions on this, you can conclude that the answer is going to be D. the relationship cannot be determined from the information given. Okay, so why don't you take a second, try and answer the problem, and then when you are ready, continue the YouTube video, and we will go over it together. Alright, so this problem is giving you a formula in the y equals mx plus b form right there, and they're asking you to plug these two numbers in to see whether b and a are greater than each other or less than each other. So that's basically what it's asking you to do. So they want you to take this function right here. This is in the classic y equals mx plus b style. Y is equal to 1/2 x plus 10. And then they're giving you 2 points, a, 0, and 0, b. Okay, so those are kind of your 2 points. So all you have to do is this corresponds to the x values, and this corresponds to the y values. So you just have to plug in the ones that you know, and you know these two. You know that this is 0, and you know that this is 0. So you have to plug these two in to this function, and you have to see what comes out for a and b, and that's going to give you what a and b are. So for the first one, this is a and 0. Let's plug a into x, so you get y is equal to 1/2. Sorry, we're going to plug 0 in for y, so you plug in what you know. So we're going to plug 0 in for y. That's what we're going to do. And we get 0 is equal to 1/2 of a plus 10. Alright, so that gives us this function right here. So then we subtract 10 over here from both sides. Cancel that. It's equal to 1/2 a multiply by 2 to get rid of this half here. So just going to multiply by 2 real quick. And we get negative 20 is equal to a. So a is equal to negative 20. Alright, so that's the first one. Now we're going to look at the second one. The second one is 0b, right? So take the same function, and now we know what the y is going to be. So we have, again, we take the function y is equal to 1/2 x plus 10, and we put b is equal to 1/2 of 0 plus 10. Alright, so 1/2 of 0 is 0, so b is equal to 0 plus 10. And then that gives us that b is equal to 10. So now we know that b is equal to 10, a is equal to negative 20, so b is greater than a. And then our answer is b is greater than a, so the answer is b. Okay, so why don't you take a second and try and do the problem, and then when you are ready to continue, whether you've solved it or whether you're not sure how to do it and you want to learn, then you can unpause the video and then we can try and do the problem together. Alright, so the way we're going to do this problem is we're going to look at the standard deviation of these two distributions. Now, standard deviation is kind of an odd thing, but instead of thinking about it in terms of its formula, just think about it in terms of what it is, which is it is a measure of the spread of the data. Okay? That's what it's a measure of. So if you think of a particular number and a data set that has a large amount of spread will have a lot of data that's all over the place, right? A lot of data a long ways away. But a data set that has a very small standard deviation will have a lot more numbers closer to the mean, closer to that center point. The more spread out your data is, the higher your standard deviation. The smaller your spread is, the smaller your standard deviation. And we can use that to figure out what the answer is here. So, distribution A, you can see that this is a frequency table. So you have whatever this is, it happens in a set of 10, and there's 3 of them, 20, and there's 3 of them, and then 30, and there's 6 of them, 40, and there's 3, and 50, and there's 3. Same with distribution B. Alright, so that's kind of how the frequency table works. And what you see here is that you have a very large amount of numbers happening right in the middle, and you have less happening on the outside. Right, so in terms of this type of picture, you have a lot happening in the middle, and then you have less happening far out. In this picture, what you have is the exact opposite. Alright, so in this picture what you have is you have very little happening on the inside and more things happening on the outside. Right, so you have very few over here, and then you have a lot more happening at the extreme ends of the data set. And what that means is this data set is going to be much more spread out than this data set. So that's all you really need to know to answer this problem. You don't need to use any formulas or even worry about calculating anything with the frequency distribution at all. You already know that because distribution B has a lot more at the ends and distribution A has a lot more in the middle, the standard deviation of distribution B is going to be greater than the standard deviation of distribution A. So the answer is B. Okay, so why don't you take a second and look at the problem, and then try and answer the problem. And when you have either answered the problem and you're ready to continue, or if you haven't figured it out, then continue the video and we can talk about the problem together. Okay, so I'll just wait a second, let you try it, pause the video, and then we'll continue. Okay, great. So let's look at the problem. It says one person is to be selected at random from a group of 25 people. So we know that there are going to be 25 people as like the total number of people in this group. Let me get my pen real quick. Okay, 25 people total. Alright, the probability that the selected person will be male is 44. Okay, so that's the same thing as 44%. So basically, if you've got a whole group of people, right, approximately 44% of them, call this 44%, are going to be male. The rest will be female. Now, the probability that the selected person will be a male who was born before 1960 is 0.28. So now we're reducing it even further. Now we're going to something like this. Alright, and now down here we've got people who are male and they're born before 1960. Okay? That's the number we have here. And we want to know is what is greater? What is greater, the number of males in the group who were born in 1960 or later, or 4? Okay, well, how do we find that out? Well, we start by saying this is 100%. Right? This is 100% of all the people in the group. Alright? 44% of them are male, and we know that 28% of them are both male and born before 1960. So what is this percentage? This is going to be the percentage of people that were born 1960 or earlier who are also male. Well, that's simply just 44 minus 28. Right, so 3, 14, carry 8, 9, 10, 11, 12. Okay, so 4, 6. Okay, 3 minus 2 is 1. Alright, so you're at 16%. Alright, now 16% of people are male and are born 1960 or earlier. Alright, now how much is that of 25 people? Okay, so that's 25 times 16%, which is the same thing as times 0.16. So we do that. 6 times 5 is 30. 6 times 2 is 12. Plus 3 is 15. That's 150. Add the 0. 1 times 5 is 5. 1 times 2 is 2. Add these. 5 plus 5 is 0, 1. 2 plus 1 is 3, 4. And we're at 400. And now we have 2 decimal places here, so we have to move the decimal place over twice, and we get 4. So 16% of 25 is 4. So the number of males in the group who were born in 1960 or later is 4. Quantity B is 4, so quantity A and quantity B are equal. Okay, so today we're going to talk about a grid answer styled question. So take a second and pause the video, try and answer the question, and then after you made an attempt, continue the video and let's go through this together. Okay, so it says for the following question, use the grid to enter your answer. At company Y, the ratio of the number of female employees to the number of male employees. So the number of female employees to the number of male employees is equal to 3 to 2. Okay? If there are 150 female employees at the company, how many male employees are at the company? Alright, so this goes over what's called a ratio problem, and this is one of my favorite types of problems. This is what it looks like every single time. You've got always these 4 items here, 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 and here. And they give you half of it, or they give you three things. They give you like 1, 2, and 3, and they say what is here. Or they give you some other combination of that. And that's what they did here. They said the ratio of females to males is 3 to 2. If there are 150 female employees, so all you do is you create this, how many male employees are there? So let's draw it out. So they say that the original ratio is 3 to 2. Alright, so that's half of what they've given me. Now they're going to give me one more of these and I have to figure out the other one. If there are 150 female employees. Okay, so they gave me the female employees. How many male employees are there? Here's where we're trying to answer. This is our x. Alright, so all you have to do now is you do what's called cross-multiplying and dividing. You start with here and you cross. Whenever you go diagonally, you multiply. Whenever you go horizontally, divide, and that will get you your answer. Alright, it's called cross-multiply and divide to get your answer. Alright, so you take 2 multiplied by 150 divided by 3. And that's how you do it. That should give you x. Alright, so alternatively you could just multiply x over here and then 2 over there. So you could get x times 3 equals 150 times 2. And then you can divide 3 out like that. And that'll get you the same thing. But you just save a step by knowing cross multiply and divide. Alright, so dividing this by 3 is 50. So you get 2 times 50 is equal to x. And then 2 times 50 is 100. So 100 is your answer. Alright, so there you go. Okay, so why don't you pause the video, take a second, try and answer the problem. Then, after you've given an attempt, start the video again, and let's see if we can do it together. Okay, so this says a minus b divided by a plus b is equal to 2 and b equals 1. What is the value of a? Alright, so let's write it out, and so let's just go ahead and say a minus b over a plus b equals 2, and b equals 1. Sorry, that's a b. Now, whenever you have two equations, and you have two variables, you can solve for the variables usually. Most often that's the case, and that's what we have. We have equation 1 right here, equation 1, and we have equation 2 right here. Alright, so let's start by solving for one of the variables, which is already done for us. B is equal to 1. Then let's plug it into the other equation. So a minus 1 over a plus 1 is equal to 2. Alright, it's a good start. Multiply this out, we get a minus 1 is equal to 2 multiplied by a plus 1. What we get is 2a plus 2 is equal to a minus 2. Pretty good so far. Let's subtract 2 from both sides, and we get a minus 4 is equal to 2a, and then let's bring that a to the other side, and we get the negative 4 is equal to a. So the answer is that a is negative 4. Look at the answers, and none of those are our answer. Fantastic. So what did I do wrong? 2a plus 2, a minus, see, I messed up right there. A minus 1 and a minus 1. This turns into a minus 3, and the answer is actually negative 3. So, anyways, silly mistakes are the bane of people's existence. Make sure you don't do that on the exam if you can help it. Yeah. But anyways, the answer is negative 3, or E. Okay, so why don't you take a second to see if you can solve the problem, and then after you've given it an attempt, continue the video and we can work on the problem together. Alright, so this problem is the floor space in a certain market is rented for $15 per square feet for 1 day. Okay, so we're looking at $15 per 30 square feet. Okay. And then square foot. Alright. Alice rented a rectangular floor space that measured 8 feet by 15 feet. Alright, so she rented a floor space. This was 8 feet. This was 15 feet. Alright, and Betty rented a rectangular floor speed that measured 15 feet by 20 feet. Okay, so this will be 20 and this will be 15. Okay, if each one rented her floor space for 1 day, how much more did Betty pay than Alice? Okay, so this is Betty and this is Alice. Okay, so now what we need to do is 15 feet for every 30 square feet. So what we need to do is we need to figure out how many square feet this is, how many square feet this is, and then we need to solve the problem. Alright, there's actually two ways of doing this. We can do it this way first. So 15 times 8, 8 times 5 is 40, 8 times 1 is 8, plus 4 is 12, that's 120. So 120 square feet for her. And then 20 times 15. 20 times 15 is the same thing as 10 times 2 times 15. So 10 times 15 is 30, and 30 times 10 is going to be 100, so 300. So that's 300 square feet here. So now what we have is we have 300 square feet here, 120 square feet here. If you divide this by 30, which is, so we know that there's $15 for every 30 square feet. We have 300 square feet here. So we divide this by 30, and we get 10. Alright, so 10 of these, so 10 times $15 dollars. And then what we get is we get $150 is how much Betty paid. And then here what we get is we get 120 divided by 30 is 4. So you get 4 times $15, which is going to be $60. So basically what happened was Alice paid 120, or Alice paid $60, and Betty paid $150. So if we subtract 60 from 150, 150 minus 60, we get $90. So Betty paid $90 more than Alice. So that is D. And that's our answer. Okay, so why don't you take a second and try and solve the problem. Then pause the video while you try and solve the problem. Then after you've attempted to do the problem, we can try and go through it together. Okay? Great. Okay, so now let's go through it. So you've got a business owner who obtained a $6,000 loan at a simple annual interest rate of R%. Alright, so I'm going to start off with saying that this is the principal amount. This is your $6,000, and then you are adding 8%. So when you add 8%, you add 6,000 times whatever that percentage is. So if it's 10% or whatever, that's the percent that you're adding. Okay. Now after 1 year, now I think we have to do, you actually have to divide by 100. So if it's 10%, you always have to divide by 100 because it's actually 0.1. Right? So if you increase something by 10%, you're actually increasing it by 10 over 100, which is 0.1. So that's what you're doing here. So that's why I do whatever percentage you're increasing, you have to divide this by 100. Alright, so that's what you did. So that's the first part, in order to purchase the computer. Alright, so obtain the loan, simple interest rate of R%. This is kind of how you write it. After 1 year, the owner made a single payment of $6,840. Alright, so the year thing isn't in here right now because this is just, but basically year would be how many years this goes through, and that gets into putting parentheses around this and adding t, and I think other variables, but I haven't really looked into this enough to know this. I don't think we need it for this problem. What we need to know is that after 1 year, so you can just call this 1 or whatever, it doesn't matter. Point is that the exponent doesn't matter for this problem. You just know that this part, after this happens one time, you end up with $6,840. Alright, so that is the final amount, and that's after 1 year of taking this, of increasing 6,000 by this amount. Alright, so great. So the question is including the interest, so that this has the interest in it, and what is the value of R? So now all you have to do is you just have to solve for R. So to do that, you just subtract 6,000, so that leaves you with 840. Alright, and then you are left with 6,000 times R over 100, and then you multiply 100 out over there, so you get 6,000 is equal to 84000, right? So that's multiplying 100 over there, and then multiply by R on this side. So then what you do is you just take R is equal to 840 000 divided by 6,000. Alright, so 84,000 divided by 6,000. So let me just grab our calculator really quick. There we go. And shorten that a bit for us here. And we get 84,000 divided by 6,000, and we get 14. So the answer is that R is equal to 14. Do we have 14? Yes, we do. So the answer is D. Okay, so why don't you pause the video, attempt to do the question, and then after you've given an attempt, continue the video, and then we'll try and do it together. Okay, great. So let's go through it now. So this question gives you two lists. It gives you lists L and list M right here. This is 2x, y, 1, 2, 3, x, and y. So these x, this x and y corresponds to this x and y. They're the same numbers. If the average of the three numbers in list L is 10 over 3. Okay, so they're giving us that. That's where I'll stop and I'll write something down. So I'll say the average of list L is going to be 10 over 3. So I'll say 2 plus x plus y divided by 3 is equal to 10 over 3. Alright, so that is the average formula. You just multiply everything in the list and divide it by the number of items in the list. That's the average that it gave us. What is the average of the 5 numbers in list M? Okay, so that's the second thing they're asking. So they want to know the average for here. So the formula for this is going to be 1 plus 2 plus 3 plus x plus y over 5 equals, and we're trying to find this guy right here. So how do we find this? Well, this is one of those things where they make it a little bit harder because they don't actually give you a situation where you can solve for x or solve for y. And that's kind of what you want to do. You want to be able to solve for one variable. But what you should do in this case is you should actually solve for a combination of variables. So instead of solving for x or y, here you have x plus y. And here you have x plus y. So what you should do is you should try and solve for x plus y here, and then plug x plus y into here. So let me show you. Here's what you do. First, you multiply this by 3. So this will get plus 3 over here, multiply by 3 over here. That'll cancel, and this will cancel. So what you'll end up with is 2 plus x plus y equals 10. I'll write that out. Alright, now you just need to get rid of this 2 by putting it over on the other side, minus 2. Alright, so there you go. And this turns into x plus y equals 8. Alright, so now you know what x plus y is. Plug it in to your x plus y right here. So what you get is 1 plus 2 plus 3 plus 8 over 5 is equal to, and you can solve for it. So 8 plus 3 is 11. 11 plus 2 is 13. 13 plus 1 is 14. So you get 14 over 5. Or 14 over 5. Don't know why I wrote it over there. But that's your answer. So now they wanted to give it as a fraction. Give your answer as a fraction. So all you do is you put 14 over 5. And then you circle this, that, and that. There you go. Hey, alright. So, why don't you take a second and try and do the problem. Pause the video, give it an attempt, and then after you've done attempting the problem, continue the video, and then we will work on it together. Alright, so let's go through this. This is about rules of exponents, really, I think. It says if 5 to the 5x times 25 is equal to 5 to the n, where n and x are integers, what is the value of n in terms of x? Okay, so when you have a problem like this, one thing to note is you can see that 5 is really important. So 5 to the 5x, and then 25 here. This is a multiple of 5, if you notice that, and this is 5 to the n. So this is kind of the first thing to notice. You have two situations where you have an exponent, and they're both in terms of 5. Now this makes me immediately think of the property where if you have a base with some exponent, plus a base to another exponent, and the bases are equal like this, then you can say that x is equal to y. You can just create that new equation here from this. So this is what we're going to try and do here. Now we don't have this in the proper format. This isn't in a base 5, but we can easily convert this into an exponent of base 5. This is just 5 squared. So what we do is we get 5 to the 5x multiplied by 5 squared is equal to 5 to the n. Alright, so now we've got everything in base 5. Now we rely on another rule of exponents. The second rule of exponents is that when you have two items with the same base again, and you are multiplying them together, x and y, like this, what this is equivalent to is b to the x plus y. Alright, this is where you take the exponents, you add them together. That's only when you're multiplying two exponents of the same base. Alright, so this is not the same thing as same base x multiplied to the y. If you have something to the x to the y, that becomes b to the x times y. But we're not dealing with this situation, we're dealing with this situation. So you can see here we have two bases and we have the exponents of 5x and the exponent of 2. So we can change this into 5 to the 5x plus 2 is equal to 5 to the n. And now we can say that n is equal to 5x plus 2. Alright, so we can say that these exponents are equal to each other because we know that these two bases are the same. Alright, so now that we know that, what is the question then? What is the value of n in terms of x? Actually, we already solved for it. So n in terms of x is 5x plus 2. And is that one of our answers? Yes, it is. That is letter B. Okay, so why don't you take a second and try and answer the problem. Pause the video, and then after you have given an attempt, continue the video and we will try and go over this one together. Okay, so this question is about inequalities. They are asking you which of the following inequalities have at least one positive solution and at least one negative solution. And the thing to think about when you look at problems like this is you want to think about the fact that when you have a number line and you've got 0 and you've got 1 and you've got -1, events that happen between -1 and 0 will have different effects when they're multiplied against things that are greater than -1, or sorry, less negative than -1, or greater or more positive than 1. So a good example would be 0.5. 0.5 squared is going to be 0.25, right? But something like 2 squared is going to be 4, and 4 is larger than 2, but 0.25 is actually smaller than 0.5. So when you multiply by 0.5 you get smaller, when you multiply by greater than 1 you get larger. So these are the type of concepts that questions like this like to play with. So let's look at what we have here. Which of the following will have at least one positive solution, at least one negative solution? So let's look at the first one. The first one is 5 over 3x. Okay, so the first one is 5 minus 3, or 5 divided by 3 times x. I have that right here, and that's going to be less than x, right? So whatever x is, we're going to be multiplying it by 5/3. Now 5/3 is greater than 1. So if this is going to be like -2, and -2 is times 5/3 is going to be negative, it's going to be more negative than -2. And -2 multiplied by 5/3 is going to be at -2 here, and it's going to go that way because 5 over 3 is greater than 1. So we know we're going there, and that's definitely going to be less than -2. So -2 times 5/3 is going to be less than -2. This makes sense, right? So this actually is true. So we have a positive situation. Now let's look at as positive values. If we take any positive value at all, let's take 1 as an example, and we multiply it by 5/3. We're going to be sitting there and we're going to say, is that going to be less than 1? Well, no, because 1 times 5/3 is going to be 5/3, so this one doesn't work. Now, would it work if it's less than 1, 0.5? Again, no, because if you have 0.5 here, 0.5 is not going to be greater than 0.5 times 5/3. And the reason why is because 5/3 makes things larger. Right? It takes whatever you're doing and it amplifies it. So 0.5 is going to be actually less than 0.5 times 5/3. So and you can try something that's larger than 1 as well, like 2 or 3 or higher, but in general this won't work. So in general A just won't work. And the reason why is because this 5/3 only makes things larger. When you have positive values, it's not going to be the case that a positive value for x is going to be greater than a positive value for x that's increased by 5/3. Okay, now let's look at this first one, at this one right here. Let's look at, for instance, let's look at let's try and go in the middle here. Let's go with 0.5s. So let's go with a negative 0.5 cubed is less than 0.5. Well, does that work? Well, negative 0.5 cubed is actually going to be negative 0.125. Is that less than negative 0.5? Actually, no, that's not the case. Negative 0.5 is right here, negative 0.125 is right here. So negative 0.125 is actually greater, and greater by being going this way on the direction line. So actually, no, this won't work. So in this situation, this inequality doesn't work. What about a larger number? So like what about negative 2? Negative 2 on this side is going to be negative 2 cubed here. This becomes negative 8. This remains negative 2. Is negative 8 less than negative 2? Yes, that does work. Okay, so this one works. Alright, so now we have a negative that works. Now, can we find a positive that works? So let's try the same thing. Instead of doing a negative 0.5, let's do a positive 0.5. We're trying both of these sections, this one and this one. 0.5 greater than 0.5 cubed. Alright, 0.5 cubed is 0.125. Is that less than 0.5? Well, here's 0.5. Here's 0.125. Yes, 0.125 is less than 0.5. So actually, yes, this works as well. So we have a yes and a yes. So we can have at least one negative and at least one positive solution. Right, so this actually is possible. Very good. Now let's look at the next one. This is x minus 6 less than x minus 7. So for x minus 6 less than x minus 7, is it possible to have both a negative and a positive solution for this? Well, let's look at it. If x is any positive number whatsoever, let's do 10 as an example. Alright, 10 minus 6 less than 10 minus 7. 10 minus 7 is going to be 3. 10 minus 6 is going to be 4. Is 3 greater than 4? No. And honestly, that's the way it's going to work for every single number, because all you're doing is creating every single number that's positive, because all you're doing is doing a horizontal shift of negative 6 here and a horizontal shift of negative 7 on the right side. So no matter what two values you pick on this line, you're going to be going, no matter what value you pick on this line, on the left side, you're going to be going this way, only 6. And on the right side, you're going to be going this way, 7. So actually, no matter what, this side is going to be less than this side, whether it's positive or negative. So this one doesn't work either, which means that B is your only option. Now you're supposed to select all that apply, but B is the only answer. Alright. Okay, so why don't you take a second and work on the problem, pause the video, try and answer it, and then after you've given an attempt, you can continue the video, and then we will work on it together. Okay, so let's look at this problem. So this has information at the top that you can see. You have two different charts. The first one is gasoline tax revenue as a percentage of total retail gasoline sales in 2000. The second one is the distribution of Germany's total tax revenue in 2000. So this question says, in 2000, the amount of Germany's gasoline tax revenue was approximately what percent less than the amount of its income tax revenue? Okay, so let's start by finding out what we're looking for. First, we want to know Germany's gasoline tax revenue, the amount of Germany's gasoline tax revenue. Well, we know that the distribution of the revenue is given over here. And this is Germany. This is we're talking about the right chart. So the amount of Germany's gasoline tax revenue right here is 20.4% of their total, the total tax revenue. That's gasoline. And they want to know approximately what percent less is this than the income tax revenue. Okay, so the income tax revenue is right here. So this is 28.6%. Okay, so these are both in relation to the total tax revenue. So this is income tax. It's 28.6 of the total tax revenue. This is gasoline. It's 20.4% of the total tax revenue. And what they want to know is they want to know what percent less than this is this. Okay. Now what's important to note here is that they are not saying take 28.6 and subtract 20.4. Don't do that, because you're not trying to find out of the total tax revenue how many fewer percentages is gasoline than income tax. They want to know, in comparison to income tax, what is the percentage decrease to get to gasoline tax? Okay. So what they're saying is, if you assume that 28.6% is your whole pie, how much of 28.6% is 20.4%? All right. So that's what they're saying for. They're saying that income tax is this. This is 28.6. And this is 20.4. Right? They're saying, what percent of this do you have to decrease to get to your to get to 20.4? That's what they're looking for. They're looking for the percentage decrease. What percent less than the income tax revenue? All right? So that's what they're looking for. So the way you do this is you set up a ratio. You say, okay, so let's say 28.6% is basically the whole pie. We're calling this 100%. Then what is 20.4%? All right, so that's going to tell us if this is equivalent to the whole pie, how much is this? All right, so we solve for that. Put an x here. All right, so we take a 20.4 multiplied by 100 is 2040. This is cross multiplication and division. So you cross multiply and divide, and that gives you your answer. So this multiplied by this divided by this will get you this. So 2040 divided by 28.6 equals x. So then we calculate that really quick. And what we're going to get is divided by 28.6. And we get that you're looking at approximately 71.32%. All right, so this is going to be approximately 71.32%. All right, so that means that if your entire percent, if 100% is your income tax, so out of your total income tax, I know this is 20% of your total tax revenue, but this is also 100% of the proportion of your total income revenue that comes from income tax. So what percentage of this is this? And what we find out is this is approximately 71.32%. And then what's left over is going to be 71.32 plus this equals this, so it's going to be 100% minus this. So we're looking for this bit. We're looking for the bit that we have to decrease to go from 28.6 down to 20.4. All right, so what we do is we take 100, which is, if we assume this is the whole pie, that's 100, and we subtract 71.32. All right, now we just round this off to 71. What we end up getting is 29. All right, so that's where we're at. It's about a 29% decrease. So 20.4 is about 71% of 28.6, which means you have to go down 29% to get here. Now, which of these answers is close to 29? Because they're saying approximately what percent less than the amount of its income tax revenue. So we look and we see the answer is C. It's approximately 30%. Okay, so why don't you take a second, pause the video, try and do the problem, and then after you have attempted the problem, continue the video and we can look at it together. Okay, so this is a problem that requires you to look at some charts and graphs. So you can see the charts and graph there on the left, the questions on the right. On the left you have gasoline tax revenue as a percent of total retail gasoline sales in 2000, and on the right you have the distribution of Germany's total tax revenue in 2000. So the question says you need to select all answers, all the answer choices that apply. And it says, based on the information given, they're talking about these two charts, which of the following statements must be true? Okay, so that must be true. Indicate all such statements. Okay, so here's the first one. In 2000, France's gasoline tax revenue as a percent of its total tax revenue was greater than 20.4%. Now you can look up here and you can say, look, this actually has gasoline tax revenue, and they're talking about gasoline tax revenue. But remember, what they're saying is gasoline tax revenue as a percent of its total tax revenue. Now this is gasoline tax revenue as a percent of total retail gasoline sales. That's not the same thing. This is Germany's distribution of total tax revenue. So this is the gasoline tax revenue as a percent of Germany's total tax revenue. But they're asking about France's gasoline tax revenue as a percent of its total tax revenue. We don't have a pie chart like this for France. We have one for Germany. And this is not talking about gasoline tax revenue as a percent of total tax revenue. It's talking about it as a percent of total retail gasoline sales. So this we cannot say. In fact, we don't have any information regarding A. B. In 2000, the price per gallon of gasoline was greater in Norway than it was in Spain. So now we have Norway and we have Spain. Now, this talks about tax revenue as a percent of their sales. All right. Now, but we're talking about the percentage. So when you have a particular sale, and then a percentage of your sale is your tax, right? That doesn't tell you how many you sold in general, and that doesn't tell you what the actual total price is in general. This is just a proportion. So you can have, for instance, Norway could be 70%, is 70% of the total 100, right? So this could be the tax, it's 70%, but the cost, like the cost for 1 gallon could be, $2 or something like that. Obviously, this is in Norway, so it won't be in US dollars. And then for Spain, it could be something like 62%, but it could be 62% of something that in total costs $4. Right? So in this situation, the price per gallon is larger for Spain than for Norway, right? But it could also be the exact opposite way. It could be that this is $2 and this is $4. The percentages can still hold, right? Because percentage is not a measure of magnitude. It's a measure of a proportion of a particular 100% of something. So again, for B, we don't know. We just don't have the information for that. So now we look at C. In 2000, Germany's gasoline tax revenue was more than 3 times its tobacco tax revenue. Okay, so now we're talking 2000 Germany, and we're talking about tobacco tax revenue, gasoline tax revenue. We have tobacco tax right here, it's 5.6. We have the gasoline tax revenue, it's 20.4. So was this equivalent to 3 times this? Let's find out really quick. And I'll just circle those a little bit better for you. So is this 3 times of this? Well, let's find out. 5.6 times 3 is equal to 15 plus 1.8. It's just breaking up the 5 times 15, and 0.6 times 3, or 5 times 3, which equals 15, and 0.6 times 3 equals 1.8. So 15 plus 1.8 is equal to 16.8. Now 16.8 is less than 20.4, so yes, it is indeed the case. The gasoline tax right here is over 3 times higher than the tobacco tax. So C is what we can say. C must be true. A and B, we don't know. Okay, so why don't you take a second, try and answer the problem. Pause the video and give an attempt. As soon as you are done, continue the video and we're going to go through this together. Okay, great. So, this problem is talking about trying to interpret graphs and charts and the information inside those graphs and charts. We've got 2 charts here, one on the left, one on the right. The first one is talking about gasoline tax revenue as a percent of the total retail gasoline sales in 2000. The second one is talking about the distribution of specifically Germany's total tax revenue in 2000. So you can see Germany is a part of this chart on the left, and this is just giving a lot more information about Germany here on the right. Now, question 20 says, if Germany's total tax revenue in 2000 was approximately 170 billion. So for this chart here, which is giving the breakdown of the percentage of the tax revenue, the total tax revenue here is 170 billion. All right, so we know that. Then, approximately what amount of the total retail gasoline sales, or what was the amount of the total retail gasoline sales in Germany that year? Now, here's the important thing to note. This is talking about total retail gasoline sales. Okay? And it's given in terms of the percentage that is gasoline tax revenue. So gasoline tax revenue makes up 70.7% of your total gasoline sales. Gasoline tax revenue also makes up 24% of your distribution of Germany's total tax revenue. And we know the total tax revenue. So we know that there's 170 billion in total tax revenue. I'm not going to put billion down here, but we just know that the unit is billions. We also know that of this 170, 20.4% is going to be your gasoline tax. Now we're going to call that gasoline tax revenue. Alright? Now we also know that of your total gasoline sales, whatever it is, X let's call it, of those total gasoline sales, 70.7% is going to be your gasoline tax revenue. So we know both of these things. Alright? So now what we need to do is we need to solve for X. So we take the information we have here to solve for this, plug this into here, and then solve for this. Alright, so let's do that really quickly. Alright, and what we do is we take 170 billion and we multiply that by 0.204. Right, that's 20.4% is 0.204. You just take 20.4 divided by 100. So we get, 170 times 0.204. There you go. That makes more sense. Okay, so now we got that. Now what we need to do is we have here 34.68. Plug this in here. So this is 34.68. And now we need to solve for x. So the way we solve for x is we divide by 70.7. So we take 34.68, we divide that by 70.7. Well, actually, sorry, change that. We divide that by 0.707. And that's because 70.7% is 0.707 because we've divided by 100 again. And what we get is 49.0523. So 49.05 ... This is pretty darn close to approximately 50. So we're looking at 50 billion as our answer, or E. Okay, so why don't you take a second and try and answer this problem. Pause the video, and then when you are done, continue the video, and we will try and do it together. Okay, so let's do the problem. So it says of the 180 judges appointed by a certain president. Okay, so there are 180 judges. 30% were women. 25% were from minorities. Okay, so that's what we're looking for, or that's kind of our information. Now they're also telling us that 1/9 of the women, so of the 30%, 1/9 of the 30% were both women and were from a minority group. So how many of the judges were neither women nor from a minority group? Okay, so we're looking for the people that were neither women nor from a minority group. Okay, so we need to find out what we're looking at here. So we're sitting with a few situations and there's some overlap. So we've got women, we've got minorities, and we've got women who are minorities. Alright, so let's start off with what we got here and here. 180 times 30%. So that's what we're going to want to do first. 180 times, no, it doesn't matter. Let's just get a calculator out and do it, because I think we're allowed to have a calculator out and test. So I got a calculator, and we do 180 times 0.3. That gives us 54. So 54 people were women. Alright, so that's what we got there. And then of those 54, 1/9 of them were also minorities. Okay, so let's divide 54 by 9, and we get 6. So we've got 54 is in this whole circle. 54, sorry. That's 54. And then we've got 6 were in this area of the circle. So this is going to be 6. This whole thing is going to be 54. And then how many are minorities? You take 180 divided by 4 or multiply by 25%. And the reason why you do that is because, as you can see, 25% of 180 is the number of minorities. So 180 times 0.25 is going to be 45. So you get 45 in this whole thing. So this whole thing is going to be 45. So, so this whole thing, so what is the probability of being W or M? So W or M is going to be equal to W plus M minus the intersection. So this whole thing plus this whole thing minus the intersection. Minus W and M. Alright, so W is 54, M is 45, right? Minus 6. And what we're looking at is going to be 54 plus 45 is 99, I'm thinking, right? 50 plus 40 is 9, 5 plus 4 is 9, minus 6 is going to be equal to 93. So this is the number of people in this whole intersection. But we want to know is how many of the judges appointed were neither women nor minority groups. So we want to take this number, which is the number that were women or minority groups, and we want to subtract that from 180, which is the total group. So that's 180 minus 93. We can do this if you want in your head, but 180 minus 93 is 87. So we are looking at 87 people, or letter C, as our answer. Okay, so why don't you take a second and try and do the problem and pause the video. Then after you've attempted to do the problem, continue the video and we'll try and go through it together. Okay, so this problem says if an integer is divisible by both 8 and 15, then the integer must also be divisible by which of the following? Okay, so in order to solve this kind of problem, what you need to know is you need to know prime factorizations. So you've got 8 over here and you've got 15 over here. And you want to know what are their prime factorizations. So for here you go, it's 2 times 4 and it's 2 times 2. Every single number can be broken down into a series of a unique identifier, which is the unique number of primes or set of primes that lead to that number. So for example, 15 is 3 and 5. No other number can be broken down into just 3 and 5, but 15 can. Similarly with 8, it's 3 2's. Okay, so now what we're looking for is one of these numbers that has this is 3's, should be 2's. I'll make that change real quick. What we're looking for is a number on the left side, one of our options, that encompasses or is within this set. Alright, because remember, a unique identifier. These are unique identifiers, so every single one of these, if taken in combination like 2 and 3, like if we just took these two, would lead to a unique number, 6. No other set of primes will lead to 6. Right, so we need a combination of the numbers that we've found, the 2, 2, 2, 3, 5, that comes out of this number, because whatever number this is, the prime factorization of this number, if we can create it out of what's here, then we know that the bigger number can be broken out into this subset of primes as well. Because whatever bigger number we have that's divisible by 8 and 15, its list of primes includes these 5 and then potentially others. But if we can find out from this the prime factorization of any of these numbers that that the prime factorization of any of these numbers is a subset of this, then we know that this is part of the prime factorization of the larger number that is divisible by 8 and 15, and therefore it's divisible by that number. So that's what we're looking for. So we go through each option. We say, okay, can we find a number whose prime factorization is subsumed under this set? So let's look. So we start with 16. 16 is 2 times 8, which is 2 times 4, which is 2 and 2, right? So now we have 2, 2, 2, and 2. 4 2's. Do we have 4 2's here? No, we don't. We only have 3. So 16 doesn't work. Now we can look at 24. 24 is going to be 4 times 6, and that is going to be 2, 2, and this is going to be 2 and 3. Do we have this? Do we have 3 2s and 1 3? Yes, we do. We have 3 2s and 1 3. So this is really good. Now, if we want to check the other answers, we can look and see that they don't work. So you've got 32. You've got 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. Right? So 1, 2, 3, 4, 5. That won't work. Too many 2's. We only have 3. So definitely not a subset of this. And we finally go to 45. 45 can be changed into 9 times 5. 5 is a prime. 9 can be changed into 3 times 3. So we have 2 3's and 1 5. We do have a 3 and a 5 here, but we need another 3, and we don't have that. So as you can see, all of these go above and beyond what we know about this number, which is whatever this number is, it's divisible by 8 and 15, which means it's divisible by 2, 2, 2, 3, 5. This is part of this bigger number's prime factorization. And we can already see that this number, when you break it down, fits within what we already know about the prime factorization of the larger number. So therefore we know that this number, that the larger number is divisible by 24. So we're going to go with B as our answer. Okay, so why don't you try and answer the problem, pause the video, and then after you've given an attempt, when you're ready to continue, press play and we will try and go over the problem together. Okay, so a certain experiment has 3 possible outcomes. Okay, so you know that there are 3 possible outcomes. Outcome 1, let's call outcome 1, outcome 2, and outcome 3. Now, the outcomes are mutually exclusive. What mutually exclusive means is that they don't overlap. If 1 happens, 2 and 3 can't happen. If 2 happens, 1 and 2 can't happen. Same thing for 3. If 3 happens, 1 and 2 can't happen. Alright, so they have probabilities that are respectively P, P over 2, and P over 4. Okay, so what is the value of P? Okay, so whenever you have some sort of outcome, there's always going to be a proportion of 1 as the total, right? So, I mean, if you have a 50-50 chance for a coin, right, a coin is going to have a 0.5 chance of landing heads, a 0.5 chance of landing tails, and if you add the outcomes of heads and tails, you get 1, right? And these are also mutually exclusive events, right? If heads happens, tails can't happen. And in, the other way around, if tails happens, then heads can't happen. Alright, so if tail happens, can't happen. Okay, so that's the whole point. So what we're basically saying there then is we have a very similar situation, except we have 3 events. Alright, so what we have is we have a situation where event 1 has a probability of P happening, event 2 has a probability of P over 2 happening, and event 3 has a probability of P over 4 happening. And there's no other possible outcomes, right? It actually has only 3 possible outcomes. So we have these 3 outcomes. In total, they will accumulate to 1, and they're mutually exclusive, which means that they don't overlap, so you don't need to worry about double counting an event. All right, so double counting an event would be if you have 2 events that could happen, A and B, and A has an event space like this, and B has an event space like this. There's a situation where both A and B can happen. And if that occurs, then what you need to do is you need to find the probability of A. You need to add that to the probability of B. But then you also need to subtract the probability that you have both A and B. Because when you add A and you add B, you're double counting this section. So you have to subtract this section afterwards. So that's why you do this. But if you're mutually exclusive, you have 2 events or 3 events or 4 events, and there's no overlap. So you don't need to worry about this. Alright, so this is what we're trying to solve. Alright, so first what we need to do is we need to, what we could do is we could just create a common denominator, and I think that's what we'll do. We'll just say this is P over 4, so we're going to change this to 2P over 4. So this is P over 4, this becomes 2P over 4, and this is P. So we need to change this to P over 4, so we're going to multiply it by 4. So that's 4P over 4. Right, so it's the same thing as over here. I've multiplied this by 4 over 4, and I multiplied this by 2 over 2. And you can do that to anything. You multiply anything by 1 or the equivalent of 1. Right? So that's what we did, and that's going to be equal to 1. So now we can bring these together, which is going to turn into 4P plus 2P plus P over 4 equals 1. 1 is equal to, just add these up, 4, 6, 7. 7P over 4 is equal to 1. P is equal to 4 over 7. So this is what we're looking for our final answer. This is what we're looking for our final answer. Okay, so why don't you try and do the problem, pause the video, make an attempt, and then after you are done, continue the video and we will try and do the problem together. Okay, so this question says in triangle ABC, so we're going to draw a triangle, and we're going to say the measure of angle B is 90 degrees. Okay, so this is a right triangle. So let's draw our right triangle really quick. Something like that. And here is going to be the 90 degrees, so we've got A, we've got B, and we've got C. Okay, so this is a right triangle. And it says the length of side AB is 4. And it says the length of side BC is X. And then it says the length of hypotenuse AC is going to be between 4 and 8. So which of the following could be the value of x and indicate all such values? Okay, so how do we find the value of x? Well, this is going to rely upon what's called the Pythagorean theorem, which is that a squared plus b squared is equal to c squared. And in this formula, a squared is going to be over here, or a is going to be over here, b is going to be here, and then c is going to be here. These aren't these are kind of just placeholders. C represents the hypotenuse, and then b and a are representative legs. So 4 is equal to a here, x is equal to b. Alright, so we need to set up 2 of these Pythagorean theorems because we are going to test the limits of this range. We're going to test a and we're going to test 4. 8 is the largest it can be, so that's the largest x can be. 4 is the largest the smallest the hypotenuse can be, so that is the smallest the x can be. So we're going to set up 2 of these. So let's do a squared plus b squared equals c squared. Alright, and a is 4, so this is going to be 4 squared plus x is b, so x squared is equal to, and we're going to do the tallest one first, 8 squared. Alright, so that's the first one. So then we get 16 from 4 squared plus x squared is equal to 64 from 8 squared. Alright, then we're going to solve that. X squared is equal to 64 minus, or let's do it down here, minus 16, which is going to be, take the 5, put the 1 over, that's going to be 8. 5 minus 1 is 4, 48. X squared is 48. So x is going to be square root of 48. Now this is the highest it can be, right? So x is going to be less than or equal to 48 square root, the square root of 48. Alright, so that's the first side right here of our thing. Now we need to find out, we found this one, so now we need to find this one. So let's do the same thing as before. A squared plus b squared equals c squared. And let's plug in for the smallest. A remains the same. This is still 4. Again, b is the same. It's just x. This is now 4 squared, because that is the leftmost amount. So this turns into 16. This stays x squared. This turns into 16. 16 minus 16 is 0. So we get x squared is equal to 0. X is equal to 0. Now, is this possible? Is it possible for a triangle to have a length of 0 on one of its legs? No. So, but what we're saying is that this is the potential range for this. Now, if it's possible, I don't think it is, but we're just going to say that x is greater than that. So x has to be greater than 0 and has to be less than or equal to square root of 48. These are our answers. Now, which of these numbers fall within this range? Well, let's look at our smallest number. 1 seems to fall within this range. Let's get our highest number, 6. Is 6 equal to the square root lower than, or a smaller number than the square root of 48? Well, let's find out. 6 squared is equal to 36. Square root of 48 squared is equal to 48. Since 36 is less than 48, 6 squared is less than 48 squared. Alright, so it turns out that actually 6 is going to be less than whatever square root of 48 is. Alright, so that's what we're looking at right now. Alright, so whatever square root of 48 is, 6 is actually smaller than it. So now that we know that actually every single one of these numbers fits. 1 through 6. So our answer is going to be A, B, C, D, E, and F, or all answers. So why don't you take a second, try and do the problem, and then after you are done, press pause on the video while you try and do the problem. And then after you're done making your attempt, we can continue the video and we can try and do this together. Okay, so it says each month a certain manufacturing company's total expenses are equal to a fixed monthly expense, some sort of monthly expense, plus a variable expense that is directly proportional to the number of units produced by the company during that month. So another expense, and this expense is proportional to the number of units. So number of units, some sort of variable rate or cost, and then a fixed cost. Okay, so that's what we're looking at. If the company's total expenses for a month in which it produces 20,000 units, so the 20,000 units right here, this is the 20,000 units, so this goes right here, and the total is $570,000. $570,000 right there. And the total expenses for a month in which it produces 25,000 units is equal to $705,000. Alright, I'm just adding our boxes again. What is the company's fixed monthly expense? So they want to know this one. They want to know the fixed monthly expense. We can add variables into these boxes now that we have some more information. We can call this X, and we can call this Y. Right? This is the rate that you multiply your production by, and this is the fixed cost that you pay every single time. And now we are sitting here with two equations and two unknowns. And whenever you have two equations and two unknowns, you want to think to yourself, is it possible to solve for these two unknowns? Because you can do what's called a system of equations, right? So let's do that first. But the first thing let's do is let's get rid of these zeros. We're going to call this 25, we're going to call this 20, we're going to call this 570, and we're going to call this 705. And we're just going to know that our answers are in thousands. Alright, that should hopefully make the math a little bit easier. Alright, so let's see what we got here. We got X is equal to Y times 20 equal to 570. Okay, so let's solve for X, and then let's plug that in to here. So we're going to take this equation, we are going to solve for X, and then we are going to plug that into this equation. So I'm going to do that over in this corner, and it's going to be X is equal to, I'm solving for X, so I'm going to take this, and I'm going to subtract it from the other side, is equal to 570 minus 20y, right? So that's I've gotten rid of this 0, so it's 20 times y, which is 20y. So 570 minus 20y, so that's what we have here. So now I know that x is equal to this. And what I'm going to do is I'm going to plug this x, and what it equals, I'm going to plug that right into x for this equation. So now what we know is that instead of x, we're going to write 570 minus 20y right here in parentheses, plus 25y is equal to 705. Okay, so now we have this, and we can try and solve for y. Alright, so negative 20y plus 25y is equal to 5y. That's good. And then we've got a plus 570 here. So now we need to get rid of the 570. So we have 705, and we're going to get rid of the 570 on this side by subtracting it over here. Okay, so 705 minus 570, I'm just going to jump on my calculator because I don't want to use up too much room here. 705 minus 570 is going to equal 135. Okay, so there you go. So this is going to equal 135 is equal to 5y, and therefore y is going to equal 135 divided by 5. 135 divided by 5 is 27. So we're looking at 27. So y is equal to 27. Now that we know that y is equal to 27, we can take this and we can plug it into our first equation. Alright, so we used our first equation, we solved for x, we put what x was in terms of y into the second equation, we solved this for y, we found out what y equals. Now we're going to plug y in to our first equation. Alright, so let's do that right over here. So now we have x plus, and now y is 27. So we got 27 multiplied by 20 is equal to 570. Alright, so that's what we're doing right here. 27 times 20 is 540. So we've got x plus 540 is equal to 570. So we subtract 540 from here, and then we get 30, and we get that x is equal to 30. Now remember, our units are in thousands. So the answer is going to be 30,000, or B. Okay, so why don't you take a second and try and answer the problem, and then after you have attempted the problem, continue the video, and then we can try and look at it together. Okay, so this is a quantity A, quantity B problem, and you need to determine whether quantity A is larger, whether quantity B is larger, whether they both are the same, or whether it's unknown. So the length of each side of an equilateral triangle T is 6 times the length of each side of equilateral triangle X. That's the information that we're given. Now the definition of an equilateral triangle is that all sides are the same. And in Euclidean geometry, what that means is that basically all angles are 60 degrees as well. This is kind of the definition of an equilateral triangle. But you can have triangles that are larger or bigger that have this. You can have another triangle that's just as large, has 60, 60, 60, and also has equivalent sides. Although these would have to be like this because they're obviously much larger than these. So anyways, that's kind of the idea behind equilateral triangles. So what we have here is we have two triangles, and they actually give us the ratio of one side of one of the triangles to the other side of the triangle. Oy, oy, oy. Let's just assume that these are equilateral rather than what they obviously look like, which is not. And these are all the same, and this is going to be equal to x over here, and this is going to be equal to 6x. Alright, so this is triangle X, and this is triangle T. So let's actually change this. Let's call this A, and let's call this A. So this has length, this side has length A, this side has length 6A, 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 A, and A. So this one would correspond to this one to that one, and this one to that one. And obviously the angles are all going to be the same. They're all going to be 60 degrees. Now, actually, this isn't necessarily that too important. This is kind of just what the picture is going to be looking like. What you're looking for is the ratio of sides to sides. So you want to know the ratio of the length of one side of T, so one side of triangle T, to the length of another side of triangle T. Okay, so that's length to length. Now, the ratio of something x to y is just x over y. So if we're looking at the ratio of 6a to 6a, we're just looking at 6a over 6a, which is equivalent to 1. So the ratio of length of one side of T to the length of another side of T is just going to be 1. Now, if we go over here and we look at the quantity B, the ratio of length of one side of X to the length of another side of X, we're still looking at the same ratio. We're looking at A over A, which is still going to be 1. So the answer is that both of these are the same. So C. Okay, so why don't you take a second and try and answer the problem. After you've given an attempt, you can continue the video and we will go through it together. Okay, so it says of 30 theater tickets sold. So right away I'm going to know that there are 30 theater tickets. Okay? Now, it says 20 tickets were sold at prices between $10 and $30 each. Okay, so I know that of these 30, 20 of them are sold, and they're sold at a range. This range is going to be $30 and $10. Alright, and I know that of these 30, 10 tickets were sold at prices between $40 and $60 each. Okay, 10 of these tickets were sold at a range between $40 and $60. Okay, so this is kind of my setup that I'm understanding, and they want to know what is greater, the average arithmetic mean or arithmetic mean of the prices of the 30 tickets or $50. Okay, so how do I start looking at this? Well, whenever I see like greater than or equal than questions, like which is greater, and I see a range is like 10 to 30, 40 to 60, what I'm thinking to myself is let's check the endpoints. check the endpoints. Right, this is the highest that we can sell all of our tickets for, and let's check the lowest. This is the lowest that we can sell all of our tickets for. If I check those endpoints, will they land on either side of 50? Will they land above 50? Will they land below 50? We have to find out, and I think if we find out that might give us a hint as to what the right answer might be. So that's generally where I go first. So now the average is going to be adding up all the individual values right up here and dividing by the number in your sample. Okay, so here if we're going to be looking at, let's go with the lowest value first. Alright, so let's look at selling 20 tickets for $10 and 10 tickets for $40. Well, on the bottom we're going to have our total, which is we're selling 30 tickets. So we keep 30 at the bottom. Then we're going to go up to our top and we're going to sell 20 tickets for $10. Now you could do 10 plus 10 plus 10 for 20 different times, but instead of doing that, what we're going to do is we're just going to say it is $10 and we sold 20 of them. Alright, or you can say we sold 20 for $10, either way, it doesn't matter. Now we're going to add the rest of what we're selling. We also sell 10 tickets for $40. So for $40, we sell 10 tickets. Okay, now that is the lowest that we can go in the ranges that were given to us. And this gives us, grab my calculator really quick. This gives us 10, well, it's not even use a calculator. We have 10 times 20 is 200, plus 40 times 10 is 400, divided by 30, which is going to be 600 divided by 30. Alright, 600 divided by 30 is 60 divided by 3. 60 divided by 3 is 20. Okay, so we've done that. That's it. So now what are we going to do? We've seen that we have found that if you have the lowest range, you're going below 50, you're at $20. Okay, now let's check the highest range. Now let's check $30 and $60. If we sell 20 tickets at $30 and 10 tickets at $60, what do we get? Alright, so we set up our average. I'll set it up over here this time. And this is going to be equal to $30 times 20 plus 10 right here, times $60. All of that over the number of tickets sold, which is, again, 30. So if we do that, we get 30 in the bottom still. 30 times 20 is 600. 60 times 10 is, again, 600. So this is going to be equal to $1,200 for 30. $1,200 total, and for 30 tickets. So how much are we at here? Well, let's divide. So we divide 1,200 by 30, which is the same thing as dividing 120 by 3. If you don't know how to do that in your head, you just do this. 3 goes into 12 4 times, leaving a remainder of 0. Bring out the 0. Now 3 goes into 0, 0, 0 times, so you add that 0 up here, and you get 40. So 40 tickets is the highest in our range. And now we see that even with the highest in our range, we don't get to $50. So quantity B is greater than quantity A, and our answer is B. Okay, so why don't you take a second and try and answer the problem after you have given an attempt, continue the video, and then we will go through it together. Okay, so it says, in the xy plane, the point 1, 2 is on line J. Okay, so we've got some xy plane here. Don't know necessarily exactly what it looks like. There's an xy plane, and there's a point here. It's at x equals 1 and y equals 2. So put that point 1, 2 is on line K. Each is on line J, and the point 2, 1 is on line K. Okay, so you go over to 2, 1, which is right here. All right, and this is 2, 1. Okay, so this is 1, 2. Alright, so 2, 1 is on line K, and 1, 2 is on line J. Each of the lines has a positive slope, okay, so you know that they're positive. So for a line to have a slope, this is a line that has a 0 slope, something that's horizontal. Okay, pretend that's a line and pretend it's horizontal. As soon as you go above that, that's a positive slope, right? When you go below that, it's negative slope. Alright, so this would have like a negative slope of like -1/2 or something like that, and this would have a slope of 1/2 or something like that. Yeah, so that's kind of like how you know that a slope is positive or negative visually. Alright, so now they want to know what is greater, the slope of line J or the slope of line K? Alright, well, generally, in order to know two slopes, like what they're going to look like, you need to have 2 points. Right? If I have a point here and I have a point here, I can tell you what the slope is because it has to cross through both of these points and it can't bend or anything like that. So that is how you know what 2 points look like. But what if I only have 1 point? Right? Well, then I have no idea, right? Maybe it could go this way or that way. Even if you're making sure it's only positive, it could go like this for an infinite number of different variations, actually. So you really don't know what the slope is except for the fact that it's positive. And that's the case for both this point and this point. So yeah, line J could be going like this, could be going like this, could be going like this, could be going like that, 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 doesn't matter. Same thing for this line. It could be going anything that's positive. And you don't know. So it could be that line J is like this and line K is like this, so that line K has a more positive slope. Or it could be that it's different. It could be that line K is going like this and line J is going like this, so that line J has a more positive slope. You just don't know. So when it comes to the slope of line J and the slope of line K, the answer is D. Not enough information. Okay, so why don't you take a second and try and do the problem. Then after you've given an attempt, we can try and do the problem together. Okay, so pause the video, try it, and then we will continue. Okay, so this says n is a positive integer, and that's basically all the information they give us. So then they have quantity A, which is the remainder when n is divided by 5, and the remainder when n plus 10 is divided by 5. And they want to know which of these two quantities is greater. So one way of going about this is looking at examples. So for example, if you have something like 9, and you divide 9 by 5. Right? So when you divide it by 5, you say, how many times can 5 go into 9? Well, 5 can go into 9 one time. Right? 5, and there's a remainder of 4. So then you subtract 9 from 5, and you get 4, and this becomes your remainder. 1 remainder of 4. Alright, so that's kind of an example. Now this is pretty high, this is 4, right? Can you have a remainder of 5? Well, you might think to yourself, well, maybe I can get a remainder of 5 by adding 1 to this, so that now instead of a remainder of 4, I have a remainder of 5. So let's add 1 to 9, and we create 10. And we divide 10 by 5. Now, what changed is that it no longer goes into 9 one time. Now 5 goes into 10 twice. And then you get 10. And then you get a remainder of 0. Alright, so hopefully what this example demonstrated to you is you can have a remainder of 4 when you have something like 9. But you can't have a remainder greater than 4, because the moment you go above 4, you go to 5 left over, you actually just have another of the thing that you're dividing into the larger number. So 5 into 9 goes once with a remainder of 4. 5 into 10 goes twice with a remainder of 0. And you can do this again and again, right? So 11 is 2 with a remainder of 1, right? Dot, 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 all the way up to 14, which is 5 minus 10, which is a remainder of 4 again. Alright, so again, you can have your remainder from 1 to 4, basically. That's what you have for for quantity A. Now let's look at the remainder when n plus 10 is divided by 5. Alright, so then let's take this example. Let's take 19. So 9 was 1 with a remainder of 4. 19 is 9 plus 10. So if we divide 19 by 5, 3, 15. Subtract 15 from 19, and again we get a remainder of 4. Alright, and the reason why is because we actually aren't changing the amount that's left over. We have some amount that you are divisible by 5. So I think visually the way we could look at it is you have, let's say it's something like 14. Let's say this constitutes 14. 10 of this, right about here, 10, is divisible by 5, right? Right, it's divisible by 5. Now let's say you add 10 more to it. All you're doing is you're adding that same amount, and we both know that same amount is divisible by 5. The little bit that's left over is going to be this extra 4. That extra 4 will always be left over, no matter how many sets of 10 you add to a number. You'll always have this little bit extra of 4. So no matter how many times you do n plus 10, the remainder will be the same when you divide by 5. So actually, if you have n divided by 5 has some remainder, we don't know what it is. And if you have n plus 10 divided by 5, it's going to have some remainder. Even though we don't know what it is, it's going to be the exact same as n divided by 5. So the answer for these two questions is going to be B. Both quantity. Oh, sorry. It's not going to be B. It's going to be C. Both quantities are the same. Alright, so why don't you take a second and try and do the problem, and then after you've given an attempt, continue the video, and then we can go through it. So pause the video now, try it, and then when you resume the video, we'll go through it together. Okay, so this is a right circular cylinder with radius 2 inches, has volume 15 cubic inches. Alright, and they want to know quantity A, the height of the cylinder, or quantity B, 2 inches. Which one is greater? Alright, so let's see if we can figure it out. Let's start by knowing that this is a right circular cylinder with radius 2 inches. Alright, so this is a cylinder of some sort. Like this. Ooh, that is not good. Something like this. Try and make that a little bit better. This is a cylinder, and it has a radius of 2 inches. So from the center of the bottom of the cylinder, at the bottom, so the center of the circle, the bottom circle, we're talking about a 2-inch radius. Just like that. It has a volume of 15 cubic inches. So volume is equal to 15. Alright, well, what is the volume of a cylinder? Well, the volume of a cylinder is equal to pi r squared times height. Pi times the radius of one of those circles squared, and then times height. So another way of looking at this is that volume is equal to the area of one of the little circles multiplied by the height, but we usually just go with pi r squared times height because it's more useful generally when we're doing calculations like this. Alright, so we can actually now plug r in to this formula, and we can also plug the volume that we know in to this formula. Alright, so why don't we do that right now? Volume is going to be 15, so if 15 is equal to pi times, and then r radius is 2, so 2 squared times height. Alright, so then what we end up getting is 15 is equal to pi times 4 times height, and then we get that height, the height of this cylinder, is equal to 15 divided by pi times 4. Now, what is 15 divided by pi times 4? Well, not necessarily certain. It's kind of hard to do that in your head, definitely. But we can do pi times 4 as an approximation, right? Pi is equal to 3.14 as an approximation. 4. Let's just multiply this by 4. 4 times 4 is 16. 4 times 1 is 4 plus 1 is 5. 4 times 3 is 12. So you get that. There are 2 spaces here, so it's about 12.56. So we've got 15 divided by pi times 4 is approximately 12.56 is equal to height. Alright, so this is the height of our cylinder. So let me ask you guys, what is greater, 2 inches or 15 over 12.56 inches? This is pretty close. Like 15 over 15 is 1. Alright, so 15 over 12 is a little bit greater than 1, but 15 over 15 is 1. Right, 15 over 12 is that's less than, it's a little bit greater than 1, I think, right? You've got a little bit over 1, but it would be something like 15 over 7.5 that it gets you all the way to 2. 7.5 times 2 equals 15, and 12.2 is 24, which is way more than 15. So whatever this value is, it's between 1 and 2. It's 15 over 12.56 is less than 2 and greater than 1. That's kind of the area it falls in. And therefore, since this is 2, we know that quantity B is greater than quantity A, so our answer is going to be B. Okay, so why don't you try and do the problem, pause the video, give an attempt, and then once you have given an attempt, continue the video and we will work on it together. Okay, so here it says k is an integer for which 1 over 2 to the 1 minus k is less than 1 over 8. And they want to know what is greater, quantity A, which is k, or quantity B, which is -2. The trick to understanding this problem is to recognizing that 8 can be written in the form of base 2. Alright, and they give you the hint by drawing this in the form of base 2. So you have 1 over 2 to the 1 minus k is less than 1 over, and then you can rewrite 8 as 2 cubed. Let me draw that out really quickly just to make sure people get it. 8 is equal to 2 times 4, which is equal to 2 times 2 times 2. Alright, just broke up the 8 into 2 and 4, and then the 4 into 2 2's. Now this is the same thing as 2 cubed, so you can write this as 2 cubed. Now that you have these, you can see they're kind of in the same form, you can actually do a rule of exponents, which is where you bring the exponent to the top of the equation. Alright, so what we see here is that you have 2 to the, and I'm going to put these in parentheses, 1 minus k in parentheses, negative is going to be less than 2 to the negative 3. Alright, so now what I did is I just did a rule of exponents. A rule of exponents here is if you have 1 over a, or if you have 1 over x to the a power, that is equal to x to the negative a power. Alright, that's just kind of how you can rewrite this as this. Alright, so it's just a way you can do things. So that's what we did. We took 1 minus k, we made a negative 1 minus k. We took 1 over 2 cubed, and we made it 2 to the negative 3 power. So that's what we have here. So now what you see is that 2 to the negative 1 minus k is less than 2 to the negative 3rd power. Okay? Now how can this work? Alright, so the only way this can work is if this right here is going to be less than this right here. Alright, so the only way that this number can be smaller than this number is if the exponent that you're raising it to creates a smaller number than the exponent that you're raising this to, because the bases are the same. A good example of this would be look at 2 to the 4th and look at 2 squared. Right, 2 to the 4th equals 16. 2 squared equals 4. Alright, now if this thing was 2 to the 5th, this number would be greater. Right, it wouldn't be 4 anymore, it would be something like 32. Right, but in order for 2 to whatever this number is to be less than 2 to whatever this number is, this number has to be greater than this number. That's how it has to work. So we can actually write this as negative 1 minus k has to be less than negative 3. Alright, so that's where we start. Alright, so now we solve for this. So we divide by a negative 1, so we get 1 minus k. And we divide this by a negative 1, this turns into 3. And whenever you divide an inequality by a negative, whenever you divide or multiply an inequality by a negative, you have to flip the sign. So we flip the sign. Then you get 1 minus k is greater than 3. Alright, so then you get k, negative k, is greater than 2. So then you can, again, the reason why we have that is we subtracted 1 from this side. Then again you divide by negative 1 to get k by itself, and you get k is less than negative 2. Alright, so we have solved for k. We have found out that k is strictly less than negative 2. So that means that quantity b is going to be our largest number because k is going to be less than negative 2. Alright, good job. Okay, so why don't you take a second and try and answer the problem, and then after you have paused the video and given an attempt, continue the video, and then we will go through it together. Okay, so it says here that n is an integer greater than 0, and it wants to know what is greater, the number of different prime factors of n times n, or 9n, or the number of different prime factors of 8n. Alright, so it wants to know about prime factors. Probably a good way to start is to do a prime factorization tree. So we put 9n over here, and we put 8n over here, and we start the prime factorization. Now we don't know what the prime factorization of n is, but we know it'll be the same on both sides. We can do the prime factorization of 8 and 9, however. Alright, so let's do this. We got 2 times 4 and 2 times 2. Alright, so the prime factorization of 8 is 2 times 2 times 2. Alright. So now let's go over here. The prime factorization of 9 is going to be 3 and 3. Okay, so prime factorization of 9 is 3 and 3. Okay, so now it wants to know what are the number of different, what's greater, the number of different prime factors of 9n or the number of different prime factors of 8n. And we don't know what the factorization of n is. think that's something really important to think about. So, for example, it wants different prime factors, right? So, for instance, this has one prime factor. It's the prime factor of 3. This has one particular prime factor. It's the prime factor of 2. And what n is might change things. So, for instance, let's make n equal to 6 as an example. So if this is equal to 6, then prime factorization of 6 is going to be 2 times 3. So now, both factors, or both numbers, have a 6 in them, which means that both factors have, as part of their factorization tree, a 2 and a 3. Or a 2 and a 3, because whatever number is above here, 8 times n equals some larger number, right? And that is, so this is basically the factorization of that number is 3, 3, 2, 3, and here it would be 2, 2, 2, 2, 3. So now we have a situation where this factorization has all 2's and a 3, so it's got 2 and 3 as the prime factors, and this situation right over here has 2's and 3's as well. Okay? Now that makes sense, right? But now what if it's something else? What if this is something like 14? Alright, so let's say n is equal to 14. So let's put 14 up here, and let's put 14 here. Well, now what is the factorization? Well, it's 2 and 7, right? 2 and 7. Okay, so now let's look at the factorization for both sides. Here we have 2, we have 2, and we have a 7. So the prime factorization, the unique prime factors here is a 2 and a 7. And here we have 3, we have 2, and we have 7. So the unique prime factors of this prime factorization is 2, 3, and 7. Alright, so 2, 3, and 7 is actually one more than 2 and 7. Alright, so at this point the number of prime factors, the unique prime factors for quantity A would be larger than for quantity B. But if n equals 6, then the prime factors would have been the same. Would have been 2 and 3 for both sides. So the moment you can come up with an example with contradicting answers, one where quantity A is bigger all the time, and another where they're both the same all the time, that's when you know that you are looking at not enough information. Okay, so why don't you take a second and try and do the problem, and then after you've made an attempt and you've paused the video and tried to do the problem, continue the video and we will go over this together. Okay, so it says, working at their respective constant rates, machine 1 makes 240 copies in 8 minutes. Alright, so already I'm thinking I'm working with a rate problem. So the rate formula is rate times time equals distance. Alright, something of that nature. Alright, so we know that machine 1 makes 240 copies in 8 minutes. So they've given us the distance. They said that we make 240 copies. And they gave us the time. They say that we do it in 8 minutes. So we can then figure out what the rate is. The rate is going to be 240 divided by 8. Alright, so 30 pages per minute. Okay. Machine 2 makes 240 copies in 5 minutes. Alright, so we're now going to make this R1. R2 makes 240 copies in 5 minutes. Okay, so that's a good start. At these rates, how many more copies does machine 2 make in 4 minutes than machine 1 make in 6 minutes? Okay, so how do we do this? Well, let's start by finding out what their rates are. Rate 1 is equal to 240 divided by 8, which I think I've already said is 2040 divided by 8 is going to be equal to, 8 goes into 24 3 times, which leaves 24, remainder of 0, so 30 is equal to 30. So rate 1, this machine 1, makes 30 pages per minute. Machine 2, or the rate 2, the rate for machine 2, is 240 divided by 5. Alright, so 240, try that again, 240 divided by 5 is, 5 goes into 24 4 times, remainder of 4, bring down the 0, 5 times 8 is 40, so it's 48. So that is equal to 48 pages per minute. Okay, so at these rates, the rates that we've just found, how many more copies does machine 2 make in 4 minutes than machine 1 in 6 minutes? So now what they're asking us to do is they're asking us to put in specific times into our rate functions that we just found, into our r times t equals d. So we now know the rates. The rates is 48 and 30. Let's write this function with the new time and our known rates to find our final distance. Alright, so machine 1. For machine 1, you are going to be working for 6 minutes. You are going to make approximately 30 pages per minute, which is going to lead you to a total of 30 times 6 is 180 pages. Just so everyone knows, we just did the rate multiplied by the new time is equal to the new productivity. Let's call it productivity. Usually I say distance because I generally think of this in terms of a distance problem, but it's just the total amount they're able to produce. Or production might be a better idea. Alright, so that's machine 1. Machine 2, working for 4 minutes, which they gave us, gets us, and at a rate of 48 pages per minute. So the rate is 48 pages, number of minutes is 4 minutes, and that equals to 48 multiplied by 4. 4 times 2 is 4 times 8 is 32. 4 times 4 is 16, 17, 18, 19. 192. 192 pages. Alright, so machine 2 can make 192 pages in 4 minutes. Machine 1 can make 180 pages in 6 minutes. And they want to know how many more copies does machine 2 make. Alright, so let's take 192, subtract 180. And what do we get? Oh, we get 2, 1, 12. The answer is B. Okay, so why don't you take a second, try and do the problem, pause the video, and then after you've given an attempt, continue the video, and we will try and do this together. Alright, so it says among the people attending a convention in Europe, 32% traveled from Asia, and 45% of those who traveled from Asia are women. What percent of the people at the convention are women who traveled from Asia? Alright, so this is a classic probability problem. So you start with your total universe, which is just the people at the convention. And if they don't give you a number, it's always nice to start with 100 as your example, but we'll get to that later. Start with people at the convention. This is the at convention. So that's your universe. Now within your universe you have people who traveled from Asia. Okay, so 32% of them traveled from Asia. And then what you have is a smaller circle. 45% of the people who traveled from Asia are women who traveled from Asia. Okay, so this is kind of your ring of probabilities coming lower. Now, they don't tell you what the total probability is at the beginning, but they don't want to know what the total number of people is. What they want to know is what percent of the people at the convention are women who traveled from Asia. They don't need to know numbers, they need to know percentages. So, with situations like this, it's always nice to just set the bar at 100. Like, put an example as 100. Say there's 100 people at the convention. Alright? Now, if there's 100 people at the convention, then 32% of them are traveling from Asia, then that means that 100 times 32%, or 100 times 0.32, which is equal to 32 people traveled from Asia. So of the 100 people, 32 traveled from Asia. Alright, so that's good, you've gotten down that far. And now you want to know what percentage of the people who traveled from Asia are women. Well, you know 45% of them are. So take 32, multiply it by 0.45. Alright, that's 45% just turned into a percentage. Alright, so let's do that really quick. Alright, let's take 32 multiplied by 0.45, and we get 14.4. There you go. That's the answer. You're looking at 14.4 0.4% is the answer. Okay, so why don't you take a second and try and do the problem, and pause the video, make an attempt, and then as soon as you are ready, we can continue the video and we can try and do this one together. Alright, so it says Steve's property tax is $140 less than Patricia's property tax. If Steve's property tax is $1,960, then Steve's property tax is what percent less than Patricia's property tax to the nearest 0.1%. Okay, so let's see if we can write out a word problem from this. Steve's property tax is $140 less than Patricia's. Alright, so if you take Patricia, her property tax, you subtract 140 from it, that will give you Steve's property tax. If Steve's property tax is $1,960, alright, 1,960, then it wants to know Steve's property tax is what percent less, oh, just cross everything out there, what percent less than Patricia's property tax to the nearest 0.1%. So we got to figure that out. We don't want to know necessarily what Patricia's property tax is. We want to know what percent less 1960 is from this. So let's solve that first. So 1,960 plus, we're going to add this to the other side, plus 140 is going to give us 0, 0, 1, 9, 10, 11, 2. 2,100. Alright, so if 2,100, and this is where you can create a ratio. I love doing this. If 2,000, oh sorry, we want to know what percent less. So let's not do that. Alright, so we want to know what percent do you have to decrease. Alright, what percentage less than Patricia's property tax is Steve's property tax? So if 2,100 is 100%, then what is 1960 in terms of percentage? That's what we're trying to find. Alright, so you just create this ratio. You know that Patricia's is 100. What is Steve's? So cross multiply and divide. Cross multiply and divide means you take the 100. Whenever you go diagonally, you cross. Whenever you go horizontally or vertically, you divide. And then it gives you your answer. So 100% times 1960 divided by 2100 is, and of course whenever you do percentages you just pull the decimal over twice. We're just doing 1. So that'll be 1 times 2100, oh sorry, change that, 1 times 1960 equals 1960 divided by 2100, and we get 93%. Alright, so we're looking at 93%. Now you know none of those answers are 93%, and that's because we don't want to know what percentage of the 2,100 1960 is. That's what we just found. We want to know how much you went down from 100%. So you have to take 1 minus this answer. Alright, so in other words, 100% is 2,100. 93%-ish is 1960. So what percentage did we go down? And to do that, all you do is you just subtract 1 from this, and you see that we went down 0.07 or 7%, or 6.7% actually is the best way to say it. So this is a 6.7% decrease. So we look over here and see, do we have that? And we do. It's A. Alright, so why don't you try and take a second and answer the problem, pause the video, and then after you've given an attempt, we will attempt to go through it together. Alright, so it says the base of a triangle has length B, the altitude corresponding to the base has length H, and B is equal to 2H. So right away I want to draw a picture. Let's draw a picture. Here's a triangle. They didn't tell me it's a right triangle, so I'm just going to draw more of a standard one like this. They say the base is length H. No, sorry, the triangle has, the base of a triangle is length b. So this right here is going to be equal to length b. They say that the altitude corresponding to the base, so basically from the base all the way to the top of the triangle, if you draw a right angle like this, which is also known as the height of the triangle, by the way, has length h. Alright, and then b is equal to 2h. Alright, so that's what they've given us there. Then they said, which of the following expresses the area of the triangle in terms of h? Alright, so this is going to be trying to test you on your knowledge of the area of a triangle. So the formula for the area of a triangle is equal to base times height divided by 2. So the base is what they've given us right here, which is equal to b or 2h, and then the height is actually this altitude right here. Alright, so it will be base times height divided by 2 is equal to area. So let's fill in our variables for what we're given in our picture. So in place of h, we're actually going to put the variable h, which is what they gave us. So we'll keep that as h. For base, we're going to put b, but we don't have to because we're actually going to put 2h. And the reason why is because they want us to write this in terms of h. So what we're going to do is we're going to replace b with 2h right here, and then divide that by 2, just like this. Alright, so then you get 2h times h over 2. 2h times h over 2 is equal to 2h squared over 2. 2's cancel. You are looking at h squared as your answer. Alright, so why don't you take a second and try and do this problem. Pause the video and give it an attempt, and after you are done, continue the video and we will try and do it together. Okay, so it says how many different 2-digit positive integers are there in which the tens digit is greater than 6 and the units digit is less than 4. Alright, so we're looking for 2-digit number. Okay, so what do we know about a 2-digit number? Alright, so the tens digit is greater than 6. Okay, so both of these numbers can be anything. This can be anything from 1 to 9, generally here. This can be anything from 0 to 9. So why can this not be 0? Because like 0, 7, they don't usually write that way. It's usually just 7, right? The 0 doesn't really count necessarily. Anyways, it's not really relevant to the problem anyways. But yeah, we want a 2-digit positive integer. This is generally 1 to 9. Right here, so it could be like 19 or it could be 99. This could be anywhere between 1 and 9. It can't be 10 because then you get into a 3-digit number. So, alright, so that's what we're thinking. And then, of course, this thing can be anything from 0 to 9. The moment this becomes 10, you have a 2-digit number. So, let's move on from that. It says the tens digit is greater than 6. So this digit is going to be greater than 6. So if we are within the range of 1 to 9 and we're greater than 6, then what are we? Well, we're either 7, 8, or 9. These are our options. 3 options. The units digit has to be less than 4. Okay, so what can the units digit be then if it's less than 4? Well, the units digit can be 3, 2, 1, or 0. Alright, you can have something like 23, 22, 21, or 20. Right, that is kind of 4 different options there. Alright, so we want to know how many different 2-digit positive integers there are. Alright, well there's 3 options for the first one, and there are 4 options for the second one. So whenever you face a combinatorial problem like this, you say how many options are there for the first slot, how many are there for the second, and you just multiply those two together. So you get 3 times 4 is equal to 12, and the answer is 12. Alright, so why don't you take a second and try and do the problem. Pause the video and make an attempt. When you are done, we will go through it together. Okay, so it says Chris entered a number in his calculator and erroneously multiplied the number by 2073 instead of 2.073, getting an incorrect product. Okay, so he multiplied it by this number instead of this number. Which of the following is a single operation that Chris could perform on his calculator to correct the error? Indicate all such errors. all such operations. Okay, well here's the point. When you go from 2000 or 2.073 to 2073, what you are doing is you are multiplying this number by 1,000. You're moving the decimal over 3 times, or you're multiplying it by 1,000. So whatever we're looking for here has to reverse this. It has to bring the decimal forward 3 times. So if you multiply the incorrect, let's look at the first one. If you multiply the incorrect product, which is this one, by 0.001, what's going to happen to it? Well, if you multiply it by 0.001, you will get 1 times this, 1 times that, 1 times that, 1 times that, and then you have to add the decimal places. So 1, 2, 3. That works. That gets you back to 2.073. Sorry, that should be a 3. If you divide the incorrect product by 0.001, you're doing the opposite of this. You're actually moving it 3 more decimal places to the right. That's way too big. So this one's out. If you multiply the incorrect product by 1,000, you're actually doing the same thing as dividing it by 0.001. So this one's out. You're making it much bigger. You're taking 2073, you're adding 3 zeros to it. And that's not good. And then if you divide the incorrect product by 1,000, dividing it by 1,000 is moving the decimal over 3 places. That's good. Okay, so this one works. And this one works. Which means your answer is going to be A and B. Okay, so why don't you pause the video and try and do the problem, and then after you've given an attempt, we will go through it together. Okay, so this basically gives you some information about the frequency of states that have particular populations. This population category right here is just a placeholder. So we're looking at A, B, C, and D as just types of, as just categories that they're putting in these states in. Population, you have 0 to 1.9 million, you have 2 to 2.3 million, and so forth. And here they give you the frequency. So when you have a gray bar that goes all the way to here, which is between 14 and 16, you can assume this means something like 15. And then here, again, something like 9, and so forth. All right, so this would be 1. All right, and that's just kind of how the way this frequency table works. Now, their question is how many of the 50 states were in the 5 population categories from A through E. So they want to know from A through E, and they give you the number 5. So you know this is going to be 1, 2, 3, 4, 5, and if you include categories A and E, then you get the number 5. So you know that this is an inclusive question. You want to know the number of states that fall within these categories. So what you want to do is you want to just count up the numbers of each bar. So here you start with 15. Here you have 9. Here you have 12. Here you have 3. And here you have 4. Alright, so that gives you what you're going to be counting up. This turns into 7. So this turns into 24. So you get 24 plus 12 plus 7. 24 plus 12 is 36. 36 plus 7. 36 plus 7. 7 plus 6 is 13. 0 plus 3 is nothing, or 3. 3 plus 1 is 4, which leaves you with 43 as your final answer. So the number of states that fall within categories A through E inclusive is 43. Okay, so why don't you pause the video and try and do the problem. After you've given it an attempt, we will go through it together. Okay, so this is giving you the frequency of states by population. And so here you have 0 to 2 million population for 15 of the US states. Here you have 1 that has 10 to 12 million, or 10 to 11.9, and so on and so forth. These population categories are kind of just placeholders to kind of show you where to go so you can write about it inside of a word problem. Alright, so here's the question. It says, in 2000, the population of West Virginia was 1.8 million. Okay, so it gives you the number. That's fine. If the ratio, okay, so you're doing a ratio problem. So I like ratio problems. You have equal sign, you have this, and you have this, and these two fractions are going to be in ratio. So in 2000, the population of West Virginia was 1.8 million. Okay, so you can put 1.8 million right up here. And you said if the ratio of the population of Georgia to that of West Virginia was 9 to 2. Alright, so West Virginia was 1.8. Georgia to West Virginia was 9 to 2. So when it says Georgia to West Virginia, 9 to 2, right? So now I go that with West Virginia, you have 2, Georgia has 9. So that means if this is the population of West Virginia in 2000, and I'm going to be comparing it to this 9 to 2 ratio, the 2 goes right here. And that's where it's going to go. So you get the 2 here. 9 goes on the other side, and then the Georgia population is what they're probably going to ask us to find. And they say, in which population category was Georgia? Okay, so they don't want to know the population of Georgia, they want to know the category, which are these placeholders that I mentioned previously. Alright, so we solve for it. So consider this to be x, and you have to solve for this. And then what you do is you cross multiply and divide. And what cross multiply and divide is you either start to the left or above, and you cross multiply, so you go diagonally. And whenever you go diagonal, you multiply. Whenever you go horizontal, you divide, and then you get your answer. So you do 9 multiplied by 1.8 divided by 2 gives you x. 9 times 1.8 divided by 2. Alright, so 1.8 times 9 is, 9 times 8 is 72, I think. 9 times 1 is 9 plus 7 is 16. So you get, 9 times 7 is 72, and 9 times 1 is, okay, so 16 comes down here. Sorry for that. And you get 162. Now remember, you have to keep that decimal. So how many decimals there are up here, you have to put down here. So that's 16.2. So you get 16.2. So that is the population of Georgia. Georgia was at 16.2. And if Georgia was at 16, oh, I'm sorry. I did this wrong again, but that's okay. You want to divide this by 2. So we just did 9 times 1.8. Now you have to divide by 2. So you do that. You have 16.2 divided by 2, and that gives you 8.1. That is the population of Georgia. So that's what we're looking for. So if Georgia has a population of 8.1 in 2000, that puts it in category E, which means that we're looking for answer D. Alright, so why don't you pause the video, try and do the problem. After you've made an attempt, continue the video and we will work on it together. Okay, so what we're going to try and do here is we are trying to answer a multiple choice question, and they've given us some information. So they've given us frequency of states with populations attached to them, and then these placeholder categories. So for instance, this is 0 to 1.9 million, and there are 15 states that have 0 to 1.9 million populations in 2000. Similarly, there are 9 states that have 2 to 3.9 million. Okay, so that's kind of the information that we're given in this chart. Now the question says the number of states in the two population categories C and D was approximately what % greater than the number in the 4 population categories E through H. So what they're saying is, here's this thing. This is your original amount. How much bigger is this thing? Alright? And the way you think of this is you say, okay, so this is actually 100% of the original. So what percentage of the original is this big thing? And that's how we're going to solve it. Alright, so first let's find out what's in our categories. C and D is this one right here, so let's add these up. This is 3 and this is 12. So 12 plus 3 is going to be 15. The next one is categories E through H. So categories E through H is here to here. So this is going to be 4 states are in category E. 1 is in category F, so that's 4 plus 1 is 5. That's 4, 1. G has 2, and H has 4 again. Alright, so let's add these up. 4 plus 4 is, well, 4 plus 1 is 5, plus 2 is 7, 7 plus 4 is 11. So we've got 11. So E through H is 11, and C plus D is 15. Alright, so that means that our 100%, our original 100% is 11, and our new massive amount is going to be 15. So how do we go from here to here? Well, what we do is we create a ratio. Set up the equal sign, put our fractions on each side, and we say if 11 is equivalent to 100% of our original, how much is 15? And then we solve for it. We solve for it by cross multiplying and dividing. Take 100%, multiply by 15, divide by 11, and then that gives you your answer. Now, this is called cross multiplication and division, but really it's just basic algebra. What you're doing is you're taking 100%, you're putting it on the right side. You're taking 15 times 100% is equal to, and you're taking this question mark and you're multiplying it on the other side as well by 11. 11 times question mark. And then what you do is you just divide by 11 on both sides. And you cancel out this 11. And then this becomes 15 times 100 divided by 11, which is exactly what we had just did. We just 100 times 15 divided by 11, which is the same thing as 15 times 100 divided by 11. Alright, so that's what we do. So what is 15 times 100% divided by 11? So let's use our calculator. We don't have to. It's not too complicated of a problem, but we can do it. Actually, I have the answer right there anyways. But this is going to be 15 times 100. Now, whenever you multiply by 100%, you actually want to take the decimal and put it over, right? 100% in decimal form is actually going to be 1. So 100% is equal to 1 in decimal form. Alright, so that's what we're going to multiply by. We're multiplying it by 1. And that just gives us 15, and then we divide by 11. And that gives us 1.363636. Okay, so you're at 1.3636. Alright, so here's where we're at. Now, this is again in decimal form. So what we want to do is we want to put this in percentage form. And the way you put a decimal into percentage form is just moving your decimal over twice again. So 1.3636 turns into 136.36%. Alright, so this is going to be the percentage of your big amount right there. 136.36. And this is the percentage of your little amount, which is 100%. So how much greater is 136.36% than 100%? Well, it's going to be 136.36 minus 100, which is going to be 36.36%. So that is the amount greater. Now that you know that, you can look for your answers. Let's see if it's near there. Here's one near there. A is 36%. I'm pretty sure that is our answer. Alright, so why don't you take a second and look at the problem, make an attempt, and then when you're ready, continue and we will work on it together. Okay, so this is going to give you the distribution of the 50 states of the United States by population in 2000. So these are placeholders, this A, B, C, D, E, F, G. This is actually giving you information about what the population was in a broad way. And then this is giving you the number of states that fit within these categories. So, for example, 15 states had a population of 0 to 1.9 million in 2000. 9 states had a population of 2 to 3.9 million, and so on and so forth. Okay, so that's the information that the chart is trying to give you. Now, the question that they are asking is, the median of the 58 state populations was in which population category? Alright, so whenever you have a median, what you do is you rank things from lowest to highest. And then what you do is you basically, like, let's say you got like 5 numbers, you know, A, B, C, D, E. Right, so these are 5 numbers. Basically cross off the largest and the smallest, until you find yourself in the center. And you pick the center one, that becomes your median. Now if you have 2 in the center, like let's say like C and C prime. Let's say these are 2 numbers in the center, so it's like an even number of questions, and the even number of questions has a so you can't pick a middle one. What you can do is you can divide this. So you basically add C plus C prime, and you divide by 2. That's what you're looking for. But we aren't necessarily looking for just this, and we're only looking for a broad stroke. Which category is it in? So we can just start canceling off the lowest and the highest, and then find the category that we're in. Alright, so let's start off with this. Here we know we have 15 that are in 0 to 1.9 million. So if we cross this out, this category, we have to cross out 15 states going the opposite direction. Because this is already in decreasing to increasing order. Right? These are the smallest population states, these are the highest. So let's see if we can cross off 15 going this way now. So 4 gets crossed off. 4 plus 2 is 6, that gets crossed off. Plus 1 is 7, gets crossed off. Plus 4 is 11, that gets crossed off. 11, 12, 13, 14, that gets crossed off. And we've we've now we've crossed off 1 of category C, right? So 4 and 4 is 8, 10, 11, 11 plus 3 is 14. Yeah, okay, we crossed off 1 here, and that's all just getting rid of category A. Now we need to get rid of this category. This one, so now we've crossed off everything from the bottom side. We've simultaneously crossed off things from the top. Now we're going to do the same thing over again. The number we have to cross off here is 9. So let's say we cross off 9 here. Now we cross off, going the opposite direction, 9 more. So there is currently 11 left in here. We already crossed off 1. So if we cross off 9 here, we're going to get all the way down to about here, where there's going to be 2 left over. Alright, and we've already crossed off this entire thing, so they're actually going to meet here. There's going to be 2 states we probably would have to divide here, but we don't have to because we know that they're in this category. We are in category C. So the median is going to be in category C, which is going to be option C. Okay, so why don't you take a second and try and do the problem, and then after you have given an attempt, we can work on it together. Okay, so it says here cube root of x is equal to 3, and x is equal to square root of y. So what is the value of x? Alright, so what they're hoping you're going to do is they're hoping you're going to take y, and then this part right here, you're going to plug it in through the association with x to here, into this function, and then you're going to solve for the whole thing. So let's go through it step by step. So we've got cube root of x is equal to 3. And we have x is equal to square root of y, right? So we know that x is here and x is here. So we can take y and we can plug it in for where x is right there. So that becomes cube root of square root of y is equal to 3. Okay, so that's what we have now. Now, one of the properties of roots like this is that you can turn them into exponents of fractions. So a square root of y, that's just a square root of y, is equal to y to the 1/2. Alright, this is just a property of what you can do with exponents. And it works with the number that's under the root. So a third root of y, for example, this isn't part of the problem, but that is equal to y to the 1/3. Alright, so you can do that with any number of root that's up here. Okay, so let's see if we can use that for the problem that we're doing. So here we have square root of y. That turns into y to the 1/2. So that is y to the 1/2 in parentheses. And then this number is taken to the third root, and that all equals 3. Alright, so remember, if the cube root of y is equal to y to the 1/3, if this relationship works, these y's aren't the same as this y, this is just an association I'm trying to show, then what we can say is if we have y to the 1/2 taken to the 1/3, what we actually have is we have y to the 1/2 taken to the 1/3 power, just by the association that I had showed you previously over here. And that is equal to 3. Okay, so now we can work on another property of exponents. The second property of exponents is that whenever you have, so for instance, you have a to the b, and that taken to the c. So a to taken to some power b taken to another power c. What you have is a to the b times c. This is just another property of exponents that you can use. So we can do that over here. We get y to the 1/2, and it's taken to the 1/3 power, which means we can multiply the 1/2 by 1/3 equals 3. And then we get, that leads us to y to the 1/6, right? 1/3 times 1/2 is 1/6 equals 3. Alright, so we have y to the 1/6 equals 3. Now how do we solve for this? Well, pretty simple. We just take everything to the 6th power. Y to the 1/6 taken to the 6th power is equal to 3 taken to the 6th power. Alright, and then that will lead us to y being equal to, and then we just need to take 3 to the 6th power. We don't necessarily need a calculator for this, but I think I'll use it. You get 3 times 3 times 3 times 4, 5, 6. And that gives you 729. So the answer is 1, 2, 3, 4, 5, 6. The answer is y is equal to 729. So just put 7. Oh, sorry, I'll do it that way. Just go up here. We do 7, 29. I think this is like a positive negative thing, so I guess I just put positive. I'm not really sure what that means. But yeah, there you go. Okay, so why don't you take a second and try and do this problem, and then after you have given an attempt, continue the video and we will work on it together. Alright, so it says that the figure shows the standard normal distribution with mean 0 and standard deviation 1, including approximate percents of the distribution corresponding to the 6 regions shown. Alright, so this is kind of just the normal standard deviation, right? This is kind of what you call the 68, 95, 99.7 rule, but they're just giving you a distribution of something in general. This is called the standard normal distribution. Alright, so it has a mean of 0, has a standard deviation of 1, and within this you have 68% of the population of whatever you're measuring. Within this you have an additional 14, an additional 14, an additional 2, an additional 2. Alright, so that's what they're showing you, that's what they're working with. Pretty standard thing that's used in statistics. And they're telling you Ian rode the bus to work last year. His travel times to work were approximately normally distributed, with a mean of 35 minutes and a standard deviation of 5 minutes. Okay, so they're saying approximately normally distributed, which means there can be like a direct analogy between this and between his distribution of travel times. So you can write something like his distribution just like this up here. And you can say that it had a mean of 35, like this. This is 35. And it had a standard deviation of 5. So every single 5 units that you go up, you are going to be taking about 14% of the distribution of his travel times. So in general, he's 35 minutes. Sometimes he goes pretty fast. Sometimes he goes in 30 minutes. Sometimes it takes longer. It takes 40 minutes. And then, of course, for the very, very fast times, he does it in 25 minutes. And for the very, very slow times, he does it in 45 minutes. Okay, so that is... Oh, change that, make that a little bit better. That is basically a way to represent what they're talking about here. Alright, so according to the figures shown above, so this is the figure, approximately what percent of Ian's travel times to work last year were less than 40 minutes? So we need to see ones that are less than 40 minutes. So what they want is they want this and below. They want this section right here. Okay, so the way you do that is you take the times that they gave you. Oh, sorry, this should be 34. I'm so sorry. Fix that really quick. 34. This is 14. This is 14. And this is 2. Okay, that makes more sense. Alright. Good. And there. Okay, so we want to find what's 40 and below. So the way we find 40 and below is that we add up the parts that constitute 40 and below. We add up the 34% here, the 34% here, the 14% here, and the 2% there, and that should give us the answer. So 34 plus 34 is equal to 68. 68 plus 14 is equal to 4 times 8 is 12, and then 6 plus 1 is 7, 8, 82, and then 82 plus 2 gives us 84%. Alright, so that is our answer. Now, an alternative solution, which might be a lot nice thing to do, is to just take the whole pie minus what you don't get. So if we're getting everything from here down, we're actually getting 100% minus whatever is over here. So you could also just take 100 and subtract 14 plus 2, which is 16. And this will again get you to 84. Alright, 0 minus 1, so it's 0, 10, 9, 10 minus 6 is 4, 9 minus 1 is 8. In either case, the answer is going to be 84%, or E. Alright, so why don't you take a second and look at this problem, and then after you have given an attempt, you can continue the video and we will work on it together. Alright, so here it says, for all integers x, the function f is defined as follows. F of x is equal to x minus 1 if x is even, and f of x is equal to x plus 1 if x is odd. And then it tells you that a and b are integers, and f of a plus f of b is equal to a plus b. Which of the following statements must be true? Alright, so let's look at this statement right here in relation to the statement above, this one right here. If we apply f of a to this f of x thing, f of a is either going to be x minus 1 or x plus 1. We don't really know. F of b, sorry, let's call this a minus 1 or a plus 1. F of b is going to be equal to either b minus 1 or b plus 1. Alright, so that's what we know. And now we know that f of a plus f of b is going to be equal to a plus b. Alright, now the only way that f of a plus f of b can be equal to a plus b, when the moment you have a entered into the function, it changes to not a, and the moment you have b entered into the function, it changes to something that's not b. It's either minus 1 or plus 1. It has to be where a and b are right next to each other. A and b are right next to each other in a list, so it could be 2 or 3, it could be 3 or 4. I'm not really sure what it is, but this is something that has to be the case, right? Because then a plus 1 would equal b, and b minus 1 would equal a, if a is odd, right? And if b is even, or the other way around. If b is even, then b plus 1 would equal a, and a minus 1 would equal b. Alright, so these are kind of the two situations that we're working with. But now that we know that one of them is going to be even, and the other is going to be odd. And now we can answer some questions over here. Is a going to be equal to b? Definitely not. They have to be right next to each other, and they are not equal to each other, so a is out. Is a equal to negative b? Again, certainly not. They have to be right next to each other, so definitely not going to happen. You could have 0, negative 1, or 0, 1. Like, potentially you could have something like negative 1 and 1, but that even won't work because there's a 0 in between. So that will not work. Does a plus b odd? Now let's think about that. An even plus an odd, what is it? And whenever you want to think to yourself, an even plus an odd, like as a generic term, or an odd plus an odd, or an even plus an even, just use an example, and that will tell you what will happen in every single case for these type of things. So an even, let's take 6, and an odd, let's take 7. 6 plus 7 is equal to 13. Is 13 even or odd? 13 is odd. Therefore, an even plus an odd is going to be odd. This works. A plus b makes sense. Alright, both a and b are even, and both a and b are odd. Both of these are already out, and the reason we know that is because a and b have to be right next to each other. Alright, so one of them has to be even and one of them has to be odd. Alright, so we know that both a and b are out. Oh, sorry, d and e are out. So we know the only answer is going to be C. Okay, so why don't you take a second, pause the video, try and do the problem, and then after you've given an attempt, we can work on it together. Okay, so let's look at this. We've got if y to the negative 2 plus 2y to the negative 1 minus 15 equals 0, which of the following could be the value of y? Okay, so here's what I'm going to do. I'm going to change this to 1 over y squared. Whenever you have something like y to the negative 2, that's the same thing as 1 over y squared. It's a property of exponents in this way, and this will work no matter what number you choose in your exponent. It could be negative 5 to 1 over y to the 5th. It could be anything of that nature. So I'm going to change it to that, 1 over y squared. Then I'm also going to change this to 2 over y. Right, so that's just 2 times y to the negative 1 is the same thing as 2 times 1 over y. That's just using the same property we had here, but with this, with the negative 1 exponent, and that turns into 2 over y. So that's where we're at there, plus 2 over y, and then I'm going to bring this 15 to the other side. I'm going to have this equal 15. So whatever we're doing here, this has to equal 15. And now that I've done that, I think it's time to start plugging in some answers and checking them. And that's what I'm going to do. So I go to here and I go 1 over 3 squared plus 2 over 3 is equal to 15. And that gets me 1 over 9 plus 2 over 3, which is equal to 15. Is that? Definitely not. No, it's not. And how do we find that out? We can check this. So let's try and get these to be together. This is going to be 2 over 18. If we change 1 over 9 into 2 over 18, that's just multiplying both sides of that fraction by 2, and that gives us oh, sorry, that's not what I wanted to do. What I wanted to do was I wanted to change this into the same thing as this. So to change this, I need to get this to 9, so I multiply this by 3. So I multiply both sides by 3, and I get 2 times 3 is 6, and 3 times 3 is 9. So that leaves me to 1 over 9 plus 6 over 9, which is equal to 7 over 9. And that is definitely not equal to 15. Alright, so that's not going to work. So we try again, do a different one. Let's go with, so we did 3, that one didn't work. And then I'm going to try negative 1/3 next. So if we try negative 1/3 next, what do we get? So 1 over negative 1/3 squared plus 2 over negative 1/3. Alright, equals 15. Now this is going to be property of exponents and algebra at this point. This is going to turn into, whenever you divide by 1/3, it's the same thing as timesing by 3, and then we just have to remember that negative. So that negative is going to come into play, and it's going to become a negative, and it's going to flip. So 2 times 3 over 1, which is going to equal to 6. Here we have 1 divided by negative 1/3 squared. So what we're going to do is we're going to multiply this out. So whenever you have a fraction like this, so negative 1/3 squared, you can actually bring that fraction down. You can negative 1 squared over 3 squared. Oh, sorry, the positive goes away because you're multiplying these things by each other. So you get 1 over 9 again. So this turns into 1 over 9. And whenever you divide by 1 over 9, you are, yeah, so, alright, let's just do that really quickly. Negative 1/3 times negative 1/3. Alright, how you do that? Negative and the negative multiply, that turns into positive. 1 times 1 multiply, that turns into 1. And 3 times 3 multiplies, and that turns into 9. So you get 1/9. That's negative 1/3 squared. So 1 divided by 1/9. Right, 1 divided by 1/9 is going to be the same thing as 1 multiplied by 9. So that's going to be 9. Alright, so then we're getting 9 minus 6. Does that equal 15? And the answer is no, it does not. So that doesn't work either. But we are getting a little bit higher, right? This turns into, this is at least getting positive. This looks at fractions, and this looks at, these are 9. These are whole numbers at least. I think what I'm going to do next is I'm going to look at something like this one. Look at this one, because I think this 1/5 here is going to turn into 25, and I think that this 2 over 1/5 is going to turn into 10, and that's going to create 15. That's what I think. So I'm going to try that. And we're still working from this formula. So we get 1 over a negative 1/5 squared plus 2 over negative 1/5. It has to be equal to 15. Alright, so let's do this again. So we get 2 divided by negative 1/5 is the same thing as saying 2 multiplied by 5 and then with a negative. So that positive goes away and turns into a negative, and this turns into a 2 times 5. And then this right here becomes 1/5 times 1/5. So let's do that over here. 1/5, negative 1/5 times a negative 1/5 is going to be equal to 5 times 5 is 25. Negative and a negative becomes a positive. 1 and a 1 becomes a 1. So we get positive 1 over 25. So we get 1 over 25 minus 2 times 5 equals 15. Alright, so let's keep going. 15 is equal to minus 2 times 5, that's minus 10. And then 1 over 25 is 1 divided by 1 over 25, and that is equal to 1 times 25, so that's equal to 25. So then we get 25 minus 10 is equal to 15, which means we get 15 is equal to 15, which means this is the answer we are looking for. Let's see. Okay, so why don't you take a second and try and do the problem, and then after you have given the attempt, continue the video, and we can try and do it together. Okay, so let's look at this problem and see what we can do. It says, for the following question, select all answer choices that apply. Then it gives you 6 numbers, 3.7, 4.1a, 8.5, 9.2, and 2a. And it says the 6 numbers shown are listed in increasing order. Which of the following values could be the range of the 6 numbers? Okay, so they want to know the range. The range is going to be the lowest to the highest. So the range is definitely going to start at 3.7. Alright, so that's where we're at. Make that a little bit thicker. 3.7. That's very thick. I don't know if I like that, but let's go with it. So that's 3.7, and it's going to end somewhere. We don't know where, but where that is going to be 2a. Alright? So what we need to figure out what 2a could possibly be. And we're given what a is, or at least we're given a range for a. Right? So a is going to be between 4.1 and 8.5. So a is going to be greater than 4.1 and less than 8.5, because we know that they are increasing in order. So I'm guessing that these things can't necessarily be equal to 8.5. I'm not really sure, but I'm going to assume they can't. So we're going to assume they can't for a little bit. So if this is what a can be, less than 8.5, greater than 4.1, then what can 2a possibly be? Well, you multiply a by 2 here, and that gives you 8.5 times 2, which is 17, and 4.1 times 2, which is 8.2. Alright, so 2a has to be less than 17 and has to be greater than 8.2. So 17 looks like it's going to be our largest one. So the largest that 2a could possibly be is 17. And the smallest that 2a could possibly be is 3.7. So we're looking from something from 17 to 3.7. And they want to know which of the following could be the range. So if you take 17 and you subtract 3.7 from it, what do you get? You get 14, I think 13.3 or something like that. Something of that nature. Let's do that just to be sure. Minus 3.7, 0.0. This turns into 6. That turns into 10. 10 minus 7 is 3. 6 minus 3 is 3. And 1 minus 0 is 1. So that is 13.3. Highest it can be is 13.3. Alright, so range to this, if this is 17, then the highest this range could possibly be is 13.3. Alright, now if you look back at our answers, 14.1 is greater than 13.3, so 14.1 is out, but 12.9 is still in. Alright, so we've managed to get rid of one of our answers. Now, what is the smallest the range could possibly be? Now, there's going to be two limiting factors to how small the range can be. It's going to be 2a, right? So 2a has to be at least greater than 8.2, but also it has to be greater than the smallest number here, which is 9.2. Alright, so 8.2, it is greater than 8.2, but 8.2 is smaller than 9.2, and this has to be in increasing order, so 2a has to be greater than 9.2. So of the two limiting factors, 8.2 and 9.2, the largest limiting factor is 9.2. So 2a has to be greater than 9.2. Alright, so if 2a has to be greater than 9.2, now we have another range we can look at, which is the smallest possible value of 2a and 3.7. So let's take 9.2, let's assume this is something like 9.2, and let's subtract 3.7 from it again. And again, we'll do something like this. 12 minus 7 is 5, and 8 minus 3 is 5, so 5.5. Alright, so whatever this range is from 3.7 to 2a, it's going to be between 5.5 and 13.9. So if we look up here, we've got 2 up here that don't fit, 4.0 doesn't fit, and 5.2 doesn't fit. So it looks like our possible answers are going to be C, D, and E.